A very good evening to all of you. My name is Deepak Arora and today we are going to discuss the smart revision of transportation engineering. So in the continuation of series Gate Vantage, right after the Gate Score Booster, so today we are going to discuss in a detail about the transportation engineering. So if you remember in the Gate Vantage series, there also we have covered the two most important concepts. One was the side distance characteristics and second was the traffic flow characteristics, right? Similarly, in a gate booster, I have taken the complete two chapters. One the geometric design of highway, second one was the traffic engineering, right? So most of the concept we have covered in those sessions, and today the final and finishing touch for you guys. Okay. So today agenda is what will we do? All the formulas, all of you know that transportation engineering is the sea of formulas. If you go through the last previous year question paper and all, I hope so all of you have noticed that one thing very important, 99% questions will be based on direct formula. The problem comes in this subject is one, remembering the formula, because very huge formulas are there in the whole subject. Second thing, what is important here? Second thing is, what's the parameter in the formula? Why? Because so much game is there in the whole subject. To convert the speed in a meter per second we have to consider, or we have to consider in a kmph, right? This is the one confusion it happens in the whole subject. Second, if you see, the number of formulas are very huge, but in the last, if you see one thing, the weightage of this subject is almost 10 to 11 marks. If you see from the last 3 to 4 years, the subject is coming almost 10 to 11 marks, right? So 10 to 11 marks is very huge for this subject, and trust me, the question of this subject will not take the time more than 2 to 3 minutes, right? All the questions, no question is there. If you see, hardly 1 or 2 may be there, but 99% questions are there of this subject, which will be done very easily and based on the direct formulas, right? So what will we do in the next 3 to 4 hours? We will sum up all the formulas, okay? And I have one thing for you. Well, while I am writing the formula, you just revise yourself in your mind, okay? Whatever formula is there, you just revise yourself in your mind. That will be fruitful for you very well, okay? So before my writing, you must remember, okay, this is the formula, right? That will be very helpful for you, okay? So now all of you know that in the transportation engineering, we have 3 parts. One is the highway engineering, second railway engineering, third one is the airport engineering. Railway engineering, airport engineering part is very small in this syllabus, but if you see the highway engineering, in that we have basically 5 chapters. One is the introduction of highway, second one is the geometric design of a highway, third one is the traffic engineering, fourth one we have highway materials, and fifth one we have is the pavement design. Okay, so basically 5 chapters are there, but from first chapter introduction part, the questions are very rare. The questions are not at all coming because mostly chapter is the complete theoretical, and GATE is not interested to ask you theory from this subject. But here again, Mayank, it's almost will take 3 hours, I think so. If you think, you only think, if I will sum up all the formulas of transportation engineering, how much time it will take, right? With only formulas, we will just learn the concept, how the questions can come. Okay, I am not going to take the questions because questions we have solved already so much here. Yeah, if we have a time, then I will take a questions. Other than that, all concepts will be covered here. Okay, all the concepts. If you have any doubt, because it is the final touch. This is the final touch of transportation engineering. After that, what you have to do, just before going to the exam, just see the formula one time. That's it. Okay, no need to do anything. All the questions, whatever have come, I will take it directly or indirectly. I will not say this is the question, but I will tell you this type of question have come already in the exam, or what's the probability of the question can come in the exam. Okay, so all the things I will summed up in next 3 to 4 hours here for you. Alright, so I already told you, like the first chapter is the introduction, which is very rare. I hope so all of you know in that you have studied about the road plans and the road patterns. Okay, so those things are there, but those questions are very rare in the exam. It's not at all coming from the last 9 to 10 years if you see. Okay, there are no questions coming from the introduction part. The question is starting from the geometric design of highway. So I am starting the subject from the geometric design of highway. geometric design of highway. So if you see, basically this chapter is divided into the 4 sub parts. The first one is cross section elements. First one is cross section element. Second one is sight distance characteristics. Second one is sight distance characteristics. Third one is horizontal alignment. Third one is horizontal alignment. Fourth one is vertical alignment. Fourth one is vertical alignment. Okay, so complete chapter is divided into the 4 sub parts: cross section element, side distance characteristics, horizontal alignment, and the vertical alignment. Now one thing may come in your mind, sir, from your, I am not in a position to comment, Guru, on this thing. Okay. So now if you see the first one, cross section elements, in the cross section element, yeah, I was saying something, the chat question came from the front. The one doubt may come in your mind also, in the transport engineering, so much data is there, right? So much data is there. So should we remember all the data? Is it required for the exam? One thing I want to say here, questions are coming from the data. It's not regular questions, but the questions are coming. I'm not saying the questions are not coming. The questions are coming from the data. Okay, but the thing is, for that 1 mark, you should do so much thing in a transportation because the data is so much huge. Okay, so I will suggest you, whatever data I am writing, just remember those data. Other data is very rare. It's a very rare in the exam. Okay, because data is very much. But standard data which I am writing here today, just remember those data. That will helpful for you the numerical. But if some extraordinary question comes in the exam, because it have come already in the exam, okay, some questions have come from the data which we generally don't know, right? So which we generally don't know, and which we generally, because they just ask the question directly from the code. So my suggestion is, no need to worry about those questions. Okay, you will find those types of questions, so no need to worry. The data which is important for us for solving the numerical, that you have to remember. Okay, that you have to remember. That's it, right? So let's start with the cross section element first. So I hope so all of you know cross section element. You study about the complete cross section of the highway. Okay, complete cross section of the highway you study in a cross section element. So how the highway looks like, I hope so all of you know. The highway diagram, if I draw the cross section of highway, in between, here it's a divider. Here it's a divider. Divider will be supported. Good evening, Rahul. The divider will be supported with the curbstone. I hope so all of you have seen. After that, pavement will be there, and pavement will not be flat. Pavement will be little inclined. Why it will be inclined? I hope so all of you know. The pavement will be little inclined, very little inclined. Okay, beta. It's not like an angle of 30 degree, 40 degree. It's very little slope is there. Very little slope is there in the pavement. After that, you will find some space. Again, after that, here it will be a one curbstone. Then again, something is this side. Same thing I will draw this side. Now see one by one what is that. First one is in the center. I hope so all of you know. This is our median or divider. I hope so all of you know why do we provide the median? To segregate the traffic from the opposite direction. This stone is called as curbstone. What the use of that curb? Curb is providing the stability to this pavement. Okay, curb is providing the stability to this pavement. Here also this is the curb, and this is our pavement. This is our pavement. I am writing one side, you can understand it will be same on both sides. This is my shoulder, this is my shoulder, again this is curve, and after that here it will be road margins. After that here it will be road margins. Road margins means it can be the footpath, it can be the cycle track, okay, it can be the bayway, roadways are there, okay. So these things will be called as combinedly it's a road margins. So my thing is here, you can see here the pavement is not flat, pavement will be provided on some angle. It will be very some slope is there, very small slope is there. That small slope is called as anyone. What do we say? This small slope is called as what? This small slope is called as what, anyone? What is small slope? What is the small slope? This is called as camber. What is the use of camber? What is the use of camber? Camber we provide for the camber. Why do we provide camber? Camber we provide for the drain of the water, right? Very good, Guru. Very good, Madhumita. We provide for the drain of the water. Camber depend upon what? Camber depends upon what? Camber depends upon. Anyone can tell me? Camber depends upon two things. One is camber depends upon two things. One is camber depends upon what? Camber depends upon what? Camber depends upon what? Camber depends upon. Camber depends upon what, beta? Camber depends upon two things. One is the type of pavement. Second one is rainfall. No, beta. It depends upon two things. One is type of pavement. Type of pavement means it's a flexible pavement or it's a rigid pavement. Okay, it depends upon flexible pavement or rigid pavement. I will come to that, Guru. Okay, so it depends upon two things. One is type of pavement, one is the rainfall. So now you will, what data we have to remember, beta? We have to remember if we have cement concrete or bituminous pavement, okay, and the rainfall is heavy, and rainfall is heavy rainfall, so we have to provide 2% camber. If we have cement concrete pavement and or bituminous pavement, but it's a light rainfall, then we have to provide camber of 1.7%. Only two data you have to remember in the camber. One is heavy rainfall, it's a 2%. One is light rainfall, it's a 1.7%. Okay, and why do we provide camber? Camber is the slope. And why do we provide the slope on the highway? You have seen it provided for the drainage purpose, right? Next thing, what are the types of camber? First camber is, what are the types of camber, beta? Types of camber, first camber is straight line camber. First one is straight line camber. Okay, first one is straight line camber. It means if we have a straight road, this is a flat road, what we do? Very good, Manumita, very good. What we do here? We rise the pavement here, because of the drainage of water. I am showing you so much rise here, beta. It's not that much rise, okay? It's very small thing. So what is the, if I say this is Y, this W is the width of pavement, width is the W, and Y is the, very good, Songa, Y is the, anyone tell me, what is that Y? What is this Y? What is this Y? What is this Y here? Y is equals, what is Y here, beta? Y is called as height of, crown. Y is called as height of crown. So first thing is, which is possible in the exam, the question may ask you what is the height of crown. So what will you do here, beta? If I say this camber is 1 by n, the equation is Y is equals to W by 2n. The equation of straight line camber is Y is equals to W by 2n. Second one we have parabolic camber. Anyone can tell me? What is the equation of parabolic camber? Similarly, we can provide here parabola. So what is the parabolic camber equation? Very good, Logeshwaran. Anyone tell me what the parabolic camber? Parabolic camber is what, beta? Parabolic camber is what? Parabolic camber is here y is equals to anyone y is equals to 2x square upon n into w. The equation of parabolic camber is y is equals to 2x square. Very good, Madhumita. 2x square upon n into w. So one thing is height of crown will be same. Either it's a straight line camber or it's a parabolic camber. You can see by road is there. If you are rising the pavement, you are providing the straight line camber or parabolic camber, height of crown will be same. Okay, the slow moving vehicles are there, that straight line camber will be helpful. The fast moving vehicles are there, so parabolic camber will be helpful. But it's not my matter. My matter is here, what is the equation of that? Y is equals to w by 2n and y is equals to 2x square by nw. Third one also we have one combined camber. Third one also we have combined camber, but no need to remember. Okay, no need to remember the. We don't have any equation of that because it will be very combined is there. So we have to go to the so much mathematics. So not required. Only straight line camber, parabolic camber you have to remember. Okay, what the purpose of camber here? The purpose of camber is to drain off the water. Second one, if you see here, we have a pavement. Second one, we have a pavement or here width of the pavement. Second one we have here width of pavement. I hope so all of you know what the width of pavement. Second one I am taking here width of pavement. Second one I am taking here width of pavement. I hope so all of you know width of pavement. Okay, if I say here it's a single lane is there, jaldi se chat box mein likh do, single lane pavement is there, what is the width? Two lane without curb, what is the width? Two lane with curb, what is the width? Everyone write fast in the chat box all the data. Okay, single lane, two lane without, two lane with, intermediate lane, last one we have multi lane, So first one, what is the width of single lane? Single lane width is 3.75 meter. Two lane without curve is 7 meter. Two lane with curve is 7.5 meter. Intermediate lane is 5.5 meter. And multi lane, what is the multi lane? Multi lane is, beta, anyone can tell me what is the multi lane? Multi lane means if number of lanes are more than 2. How do you calculate? If number of lanes are more than 2, very good. It's a 3.5 meter. It's a 3.5 meter per lane. It's a 3.5 meter per lane, beta. Okay. So multi lanes are there. What is intermediate lane meaning? Anyone can tell? What is intermediate lane meaning? Anyone can tell? What is intermediate lane meaning? What is intermediate lane meaning? What is intermediate lane meaning, anyone? What do you mean by intermediate lane? Intermediate lane meaning is, beta, anyone is writing? Intermediate lane is meaning, beta, more than single lane, less than two lanes. Okay, more than single lane, less than two lane is called as intermediate lane. Okay, more than single lane, less than, very good Songa, less than two lane is called as intermediate lane, beta. Okay. Now come to the next one here. If you see, we have one more component here, solder. What the purpose of solder? What the purpose of solder? Solder is, we provide the solder here. We provide the solder as an emergency lane, beta. Okay, we provide the solder here as a emergency lane, and the color of solder is also different than the regular pavement, and it is more rougher than the regular pavement. Anyone can tell me what is the width of solder for two lane rural highway? For two lane rural highway, what is the width of solder? For two lane rural highway, what is the width of solder? This data can be asked. For two lane rural highway, what is the width of solder? Two lane rural highway. I am writing here only for two lane rural highway, for 2-lane rural highway, rural highway, the width is very good. It's a 2.5 meter. Okay, this is all the data what I'm writing. It's a given by the IRC. So for 2-lane rural highway, 2.5 meter shoulder width. Okay, 2.5 meter shoulder width. Anyone doubt up to now? If anyone have a doubt now, immediately stop me and ask me. If anyone have a doubt, you can. Very good, Lokesh Suran. Here it's a 2.5 meter shoulder width is there. All right. So next, if you see here, what is that? Again, it's a curve. So anyone can tell me what is the dimension of this median? What is the dimension of this median or divider? What is the dimension of median or divider? What is the dimension of median or divider? Dimension of median or divider. Dimension of median or divider, whatever you want to say. What is the dimension of median according to the IRC? Anyone can tell? What is the dimension of median for the rural highway? What is the dimension? Very good, Guru Prasad. It's a 5 meter and 1.2 meter. It's a 5 meter or it's a 1. In the rural area, it's a 5 meter. In the rural, it's a 5 meter. And in urban how much it's a? In urban how much it is? In urban it is 1.2 meter. Okay, in urban it is 1.2 meter beta. So 5 meter, 1.2 meter here. All right. So this is the dimension of our median. Right. This is the dimension of our median here. Right. So this, and one more thing, the complete including the shoulder, pavement and median curve, the complete road is called as what? For complete road we use one term. How much width is required for complete this? Anyone? How much? I hope so all of you know one term, width of formation. I hope so all of you know width of formation. So complete width, how much is required for national highway? For complete width, how much is required for the national highway or state highway? Right, very good, Guru Prasad. Right of way is the different thing. Okay, very good, Bhagyasri. Versa it's not 2. Okay, you are answering the before. I think the answer is here 12 meter. Okay, so question may ask you here for NH and SH. The complete is called as here width of formation beta. This complete is called as width of formation. Okay, so for NH and SH in plain and rolling terrain, it's a 12 meter. For MDR or ODR, it's a 9 meter. Okay, for MDR or no, it's not. Madhumita, you are talking about the right of way. I am talking about width of formation here. For NH and SH, it's a 12 meter, and for this one, it's a 9 meter beta. Okay, so these two data you have to remember, width of formation, or this is called as roadway. This is also called as width of roadway. Right of way includes the boundary line, control line, building line also. Okay, Madhumita. So that I am not considering. I am just considering the road, whatever visible to you there. Okay, from the road margins to one road margin to other road margin, this is called as our width of formation. That is the 12 meter required for the plain and rolling. In plain rolling terrain for NHSH, and for MDR it's required 9 meter. Okay, so this is our cross section elements. This is our cross section elements. Right. I hope so all of one more thing you know, pavement characteristics. What are the pavement characteristics? One is the friction, second one is the skid, light reflecting characteristics, right? And fourth one is the, anyone, what are the pavement characteristics? Anyone, what are the pavement characteristics? Friction, skid, light reflecting characteristics and pavement unevenness, right? Pavement unevenness. So those things you may remember, but question is very rare from that. Okay. So this is the complete about, beta cross section element. If you see, this is the complete about our cross section element. I want you to remember data only for the camber, which will be very important. The camber data for heavy rainfall is at 2%, for light rainfall it's a 1.7%. So just you have to remember this 100% beta. No choice here. This data is very important. Okay. Now come to the next. We have side distance characteristics. I hope so all of you know side distance characteristics is the topic you will find the question in all the exam from the transportation engineering, right? So next we have side distance characteristics. Next we have side distance characteristics. All of you tell me what are the types you know of side distance characteristics. All of you tell me what are the types you know of side distance characteristics. What are the types you know? Anyone tell me first. What are the types you know side distance characteristics? What do you know about side distance characteristics? Side means beta, side means what? Visibility. Side means what? Visibility, and distance you know characteristics that we will discuss here. I hope so all of you know two things here. One is SSD, that is called as our stopping side distance. Next one I hope so all of you know, it's called as OSD, overtaking side distance. Other than that, anyone know anything else? Other than that, anyone know anything else here? Very good Saurav, very good Saurav, it's intermediate side distance. Anything else? Anything else? Anything else? SSD, OSD, anything else you know? This is my stopping side distance. This is my stopping side distance. Okay, and this is my overtaking side distance. This is my overtaking side distance. Right, now maybe you know the two more things here. One is the intermediate, very good Niket. Maybe you know the two more thing here. One is the intermediate side distance, one is the headlight side distance. Okay, so intermediate side distance or headlight side distance are the special case of these two only beta. Okay, so intermediate side distance and headlight side distance are a special case of these two only. So I am writing here as a note, one is intermediate side distance. I will tell you what is that exactly. Intermediate side distance, intermediate side distance, and next one you are saying headlight side distance. Okay, so let's start with here first stopping side distance. Anyone tell me what are the other names you know for stopping side distance? What are the other names you know for stopping side distance? What are the other names you know for stopping side distance? SSD, anyone? Stopping side distance is also called as, stopping side distance is also called as, Gate have not used that word, but I am expecting they will use the word very early, that is the non-passing side distance. Very good Bhagyasiri, non-passing side distance. Anything else? Anything else? Non-passing side distance, anything else here? Very good Saurav, anything else? Stopping side distance, stop means what beta? Not pass. If you stopped means you are not passing, it's a non-passing. Okay, we are writing the synonyms here, you can say. So stopping, non-passing side distance, anything no? Anyone know any other word here? This is also called as absolute minimum side distance. Okay, this is also called as absolute minimum side distance. This is also called as absolute minimum side distance. Now what is that? Very good Madhumita. Absolute minimum side distance. Now what is stopping side distance? It is the length of road visible ahead to the driver from a specific height to stop the vehicle safely before the collision. कोई नहीं पूछ रहा डेफिनेशन, कोई नहीं पूछ रहा डेफिनेशन क्या है यहाँ पे, ना किसी एग्जाम ने तुमसे पूछी है अभी तक क्या डेफिनेशन एसएसडी की, राइट? बट पता होना चाहिए तुम्हें, बिकॉज फॉर्मूला उसके बिना नहीं लिख पाओगे. द फॉर्मूला इज, विल राइट, बट व्हाट इज स्टॉपिंग साइड डिस्टेंस? लेंथ ऑफ द रोड visible ahead to the driver to stop the vehicle safely before the collision. It means if I consider this road, here is some vehicle, okay, here is some vehicle and here is some object, right? So if this vehicle is moving on, let us say design speed v, this vehicle is moving on design speed v. So what is the length required for this vehicle to stop here? Okay, what is the length required to stop this vehicle here so that it will not collide with the object. Object is stationary object here, beta. Object is here stationary object. So anyone can tell me, Varsa, I think you are lagging here, beta. You are lagging here with the connection. Maybe you will rejoin, it will be fine for you. Okay. So here if you see here, beta. So here the vehicle which is moving on a highway with a speed of V. Generally the V is our design speed, beta. V is here our, we assume that the vehicle is moving on a design speed. So vehicle is moving on a design speed, that is V. So how much length is required to stop the vehicle safely here? So you know here we divide the distance into a two parts. One is called as our leg distance, one is called as our braking distance. Okay, what is leg distance here? Leg distance means the distance traveled by the vehicle in understanding the whole situation, what he have to do. Okay, so that distance is called as here leg distance. That distance is called as here leg distance, right? And after that what happen? Again here speed is V. It will apply the brake, and here to here the distance is called as braking distance. Here the distance is called as braking distance, right? And let us say this distance is D1. This one is D2, and we assume that here the speed of the vehicle because the vehicle have been stopped. It means the speed of the vehicle have been become 0, beta. The speed of the vehicle have been become 0, right? So I hope so all of you know. So SSD is called as here D1 plus D2. What is D1 plus D2 formula? The D1 plus D2 is equals to D1 is V into T, D2 is V square upon 2GF. Okay, Saurav, you are right. Madhumita, you Saurav, you are writing the formula into the kmph. You are taking the speed into kmph. I take always in meter per second. It's completely your choice. If you remember the data like that, I have no problem. So V into T plus V square upon 2GF. This is our stopping side distance, beta, or non-passing side distance, right? One thing remember, how do we derive this braking side distance formula? How do we derive? By using which principle? How do we derive this expression V square upon 2GF? By using which principle? Which principle do we use here for deriving the V square upon 2GF? Anyone? Which principle we use here for deriving the V square upon 2GF? Anyone? We use here, I hope so all of you know, we use here energy conservation principle. We use here energy conservation principle, beta. By using energy conservation principle, you got this formula. So this question may come in the exam. You got the energy conservation principle, then you will get the V square upon 2GF. Very good, Bhagyasri. Then you will get the V square upon 2GF here, beta. Now V is here, all of you know design speed. What is T here? T is our, what is T here? T is our total. T is our total reaction time. T is our total reaction time, that is considered as, according to IRC, the T is considered as how much? The T is considered as how much, beta? The T is considered as how much? T is considered as how much? Anyone? The T is considered as here 2.5 second. The T is considered as here 2.5 second. T is considered as 2.5 second, which is 90 percentile of the 90 percentile time, beta. Which is 90 percentile time. What do you mean 90 percentile time? This is our 90 percentile time. It means that out of 100, 90% driver is taking the time 2.5 seconds. Okay, only the 10% vehicles are there. Those are exceeding the time more than that, beta. So 90% drivers are taking the time of 2.5 seconds only here. Okay, very good. Very good. Anyone, any doubt you can ask me, beta. Before I write the formula, you have to write in the chat box. Okay, so that will be the perfect revision for you, right? So this is our total reaction time. Now if I consider the effect of gradient here, now if I consider the effect of gradient, effect of gradient on stopping side distance, I hope so all of you know, the formula will change. The formula of SSD will become SSD is equals to V into T plus V square upon 2G F B plus minus N. I am writing here, beta. F into B plus minus N. Anyone can tell me what is B here? What is B here? What is B here, beta? B. Anyone can tell me what is B here? B is here our braking efficiency. B is here our braking efficiency. Okay, the question will give you definitely B is our braking efficiency. What is N here? N is our gradient. N is our gradient. But you can see here I am writing plus minus N. Very good, Guru Prasad. I am writing here plus minus N. So what do you mean by plus here? Plus will be used. The plus will be used for ascending gradient. The plus will be used for ascending gradient. Minus will be used for descending gradient. The plus will be used for ascending gradient. Minus will be used for descending gradient beta. Okay. And you can see one question may come in your mind. Why are we not considering the effect of gradient on leg distance? Only we have considered the effect of gradient on braking distance. We have not considered the effect of gradient on first one leg distance. Anyone can tell? You can see the gradient term is only coming in the second formula. It's not coming in the first formula. Anyone can tell me why? Anyone can tell me why it's happening? Why we are not considering the effect of gradient on a first term? Anyone? Beta, the first term is V into T. V is the design speed. Okay, because whatever speed you are moving on a gradient, the speed will be same. Okay, very good. T is our time beta. Why T is the situation time which will be used for understanding the situation. Now you are on a gradient. Now either you are on a flat road, it will be same. It will be same. Your mind will not change on the gradient. Your mind will not be changed on the flat road. Okay. So time is it's a V into T. That's why we are considering it's a same. We are not considering the effect of gradient here beta. So V into T plus V square upon 2G FB plus minus N. One more thing here. The question have come from two times from this beta. While deriving the expression for braking distance, what we did beta, the vehicle was moving here with a speed of V, and we are saying when the vehicle have been stopped, the speed have become 0 here, right? Now you will see in the GATE 2016 or GATE 2018 also, two questions have come. The two questions are there. What is the question saying there? The question is saying the braking distance is required to make a turn. Okay, or braking distance is required to reach the road which have a lesser speed beta. Okay, it means the question have not said to you the speed have become 0. The question have said to you in Doge, the question is saying to you the speed have been reduced. So I am saying, let us say here the speed is V1. Now here the speed is not become 0, here the speed is V2 beta. So now what will be this distance D2? You can see the questions or you can see my previous session in a gate vantage series or a gate booster. Okay, if this is the case, so what will be the braking distance? Okay, how much distance is required if I say it's moving on some gradient? Okay, the vehicle is moving on some gradient. It's not flat, the vehicle is moving on some gradient. Or vehicle you can say it's a flat also, I have no problem. So what will be the D2 distance here? The speed is not becoming 0, speed have some V2. The vehicle have a speed V2. So what is the D2 here? The D2 will be here beta. D2 will be here V1 square minus V2 square upon 2GF. V1 square minus V2 square upon 2GF. In this case, when the speed have been reduced to V1 to V2 beta. Okay, now if it's at a gradient, then D2 will be, if gradient is there, if gradient is present, then our D2 will become V1 square minus V2 square upon 2G again F plus minus N beta. Okay, you can check the question of GATE 2016 and 18. You will find the question on this concept. The speed of the vehicle have been not become 0. It have been reduced V1 to V2. So it will be V1 square minus V2 square upon 2G in the bracket F minus plus minus N. One thing I forgot here. What is F value? What is F here? What is F here? What is F here? F is how much? F value is how much? Anyone fast? What is F value? F value is how much? Value of F is how much? 0. Very good, 0.35. This is our coefficient of longitudinal friction. This is our coefficient of longitudinal friction. Now you may ask in the, no Guru Prasad, this is the problem, that's why I asked. Here the value 0.35, this is my coefficient of longitudinal friction beta. Okay, this is our coefficient of longitudinal friction. Okay. Now thing is, one doubt may come in your exam, sir, always we have to take 0.35. If question have not given you data beta, you consider 0.35. But if question have given you some data, okay, if question have given you some value 0.32, 0.38, 0.40, whatever, gate, 99% gate will give you the value in the exam beta. Okay, 99% the gate will give you the value of F here, that is 0.35 as per the IRC, but gate will give you the value. So don't write blindly 0.35. Whatever value they are giving, consider that value. Okay, consider that value and move ahead with the calculation part. So don't write blindly, read the question very carefully there. Okay, so this is the one special case. The question is may come on this concept. Okay, the question may come on this concept. You can check the gate on 16 question. The question have come already on this concept 2 times. Okay, all right. Now different cases for SSD. Different cases for SSD. What are different cases? I hope so all of you understood what I want to say now. Different cases of SSD. Case here SSD. I am saying if single lane, one-way traffic, single lane, one-way traffic, single lane, two-way traffic, two-lane, two-way traffic. So can you tell me what the stopping side distance value means? Ki whatever you calculate from the question, you will write same thing here, or you have to multiply here. You have to multiply with some term here. Or what you have to do? Single lane one way. Single lane one way means beta, I have one highway, on this one vehicle is there which is only moving and it's a one way. So what is the SSD? What will be SSD in this case? Whatever we are calculating, that it will be same, or I have to multiply with some term here. It will be same, or I have to multiply with some term here. What will be SSD for first case? It will be same, or I have to multiply with some. It will be very good. It will be same. It will be SSD, whatever you are calculating. Second thing, single lane two way. It means now what happened? This is my first case here. Second case is this beta. Single lane is there and two way means the vehicles are coming like that. One vehicle is coming from this, one vehicle is coming from this. Let us say the speed of this vehicle is V1, this vehicle is V2. So anyone can tell me what should be SSD now? What should be SSD now? Very good, Madhumita. It will be twice of SSD. It will be twice of SSD when the speed is same for both the vehicle. It will be twice of SSD when its speed is same for both the vehicle. I have given a different speed, so it will be SSD 1 plus SSD 2. It will be SSD 1 plus SSD 2 beta. SSD 1 plus SSD 2, because I am saying the speed is different. If the speed is same, you can see it's a twice of SSD. Last case, anyone can tell me two lane two way. Two lane two way, it will be how much? Two lane two way, it will be how much? Two lane two way, it will be how much? Again, it will be only SSD. It will be only SSD. Two lane two way. Bhagya sir, it will not twice of SSD beta. Two lane two way, because two lane means it's like that. Two lanes are there. One vehicle is moving here. One vehicle is moving here. It means both the vehicles have a no interaction, right? Both the vehicles have a no interaction with each other. So whatever you are calculating, it will be same here, right? Anyone any doubt? 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 So in SSD, one more note I am writing here. In SSD, what IRC assume? Height of driver I, height of driver I and height of object. What IRC assume? Height of driver I and height of object. Anyone can tell me? What the height of driver IRC assume here? What the height of driver IRC assume beta? According to IRC, when you are doing the calculation of very good, it's considered as 1.2 meter and height of object is considered as not 1.5 group percent, it's a 1.2 meter and it's considered as here 0. No, it's a 1.2 meter beta. It's not 1.5, it's a 1.2 meter and 0.15 meter. Okay, 1.2 meter and 0.15 meter. Okay. So 1.2 meter, 0.15 meter in the SSD calculation. This is as per the IRC. Alright, very good, Gusbu. Very good. Anyone doubt? 1.2, 0.15. So this is all about the stopping side distance or non-passing side distance or absolute minimum side distance beta. Okay, it's all about these three: stopping side distance, non-passing side distance or absolute side distance. Alright, okay, so no question may come from the outside of this, but only thing is do the calculation very carefully. Okay, do the calculation very carefully and read the last line very carefully. Maybe these cases are given to you in the exam. Okay, maybe these cases are given to you in the exam. So read the last line very carefully. Maybe you need to multiply with 2 in the last beta. Okay, only in this case you have to multiply or you have to take care. If speed is different, so SSD 1 plus SSD 2, if speed is same, it will be twice of SSD. Right? Now, one thing you already said, like headlight side distance. Here only I will write, that will be fine. Headlight side distance. What is headlight side distance? Headlight side distance is required in the design of vertical curve, that is our valley curve. Okay, headlight side distance is required in the design of valley curve. Mathematically HSD is calculated as, anyone can tell me? Mathematically HSD is calculated same as, anyone? Mathematically HSD is calculated same as, anyone? How much? How do we calculate? Very good, Khushbu. It's calculated as SSD only beta. Okay, mathematically it will be equals to SSD only. What the definition of HSD? The definition of no Nikit beta. It's a SSD only. Okay, HSD is a SSD only mathematically. Only the difference in the definition is it is the length of the road visible to the driver in a night time. Okay, length of the road visible ahead to the driver in a night time during the illumination of the lights, because lighting will be there in the night time. Okay, so whatever distance is required to stop the vehicle safely, but in the IRC we are not considering the special case for this. The name is headlight side distance, but the calculation of HSD is considered same as SSD beta. Okay, we have not given the different or higher priority to the night time condition. We are saying whatever you are providing for a daytime SSD, same will be as a HSD for the night time also. So mathematically both are calculated same as SSD beta. Okay, alright. Next is our overtaking side distance. Next is our overtaking side distance. Next is our overtaking side distance. Anyone can tell me what do we say other name of overtaking side distance? Anyone tell me fast. Overtaking side distance. Anyone can tell? What is the other name of overtaking side distance? Varsa, your connection is lagging, I think so. Just rejoin again. Anyone? What is overtaking side distance? What is the other name of overtaking side distance? Very good, Bhagyasri. The name is here again, beta. That was non-passing. This is my overtake. I have to overtake. It means I have to pass the vehicle. This is called as passing side distance. This is called as passing side distance. Also, the concept of OSD is applicable for only two-lane, two-way. The concept of OSD is applicable for two lane two-way, because if more than two lanes are there, by however you want to overtake, you can do. Okay, if more than two lanes are there, so you can do the overtaking however you want. Only the overtaking side distance concept is required in a two lane two-way beta. Okay, so I hope so all of you know how to calculate. Here we have a three distance D1, D2, D3. So what I am doing is, let us suppose we have one two lane two-way undivided road. My road is undivided beta. There is no divider, but here it's a center line. Okay, here it's a center line. It's not divider. It's a center line of the road. Alright. So what do we say here? Here we say, let us suppose we have a two vehicles, A or B. One vehicle is A, which want to overtake the vehicle. We have one vehicle here, A. The position I am saying A1, and here we have one vehicle, that is B. Okay, and here the one more vehicle is there which is coming from opposite direction. Let us say this vehicle is C. Right. So this is our condition. I hope so all of you know A1 want to overtake B. Okay. So A is our overtaking vehicle. A is our overtaking vehicle. B is our overtaken vehicle. B is our overtaken vehicle, or it's called as slow moving vehicle. This is called as slow moving vehicle, and C is our opposite direction vehicle. C is our opposite direction vehicle. Okay, and here we assume that our A and C is moving on a design speed. Initially our A and C is moving on a design speed only. Okay, both are moving on design speed, right? And the speed of overtaking vehicle here we say it's a VB beta. Here we say the speed of overtaken vehicle is VB. Okay, Guru, it will take 3 hours at least. Okay, so overtaking is design speed, overtaker moving with VB, and opposite vehicle is also moving with the design speed, right? So now how the overtaking start? Overtaking start means once the A vehicle have been B, vehicle A will reduce its speed to VB only. Okay, vehicle A will reduce its speed to VB only, and it will move some distance here. It will move some distance here, and it will reach here A2 position beta. It will reach here and it will reach to A2 position, and now here the speed of A2 is VB. Okay, the vehicle A was coming from somewhere here beta. It was coming from here on the design speed. Once he reached here, he saw the vehicle B, it have been reduced the speed to VB, and after VB it moves some distance. This distance is my, let us say this is my D1. Anyone can tell me what is D1 here beta? Vehicle A1 is moving with the speed VB. Let us suppose the time is small t. Let us suppose time is small t. So can you tell me what will be D1 here? What will be D1 here? Anyone can tell me? Speed is VB, time taken is t. Time taken is t. So what will be D1 here? D1 will equal to, very good, it will be equals to VB into t beta. What is t here? T is again here, it's a reaction time which is considered as here, how much? The time is considered as how much in a OSD beta? The time is considered how much? It's also the reaction time. Okay, how much it's considered as? It's considered as 2 seconds Bhagyasri, not 0.7. 0.7 you are talking in a 0.7 you are talking in a, I will come to 0.7 what you are saying here. Okay, it's considered as here t is equals to 2 seconds. Okay, it's considered as here t is equals to 2 seconds. So it's my D1. After that A1 have been reached to A2 position. Now A2 have been reached the mind ki I have to overtake. Now A2 have make the mind I have to overtake. So now what A2 will do? A2 will change the lane. A2 will change its lane. A2 will change its lane. It will move some distance. It will move some distance here. After changing the lane, it will go to the same lane here. It will go to the same lane here. So now A2 have been reached here beta. A2 have been reached here. This is our A3 position. Same time when A2 reached to A3, B1 also moves some distance. This is our B2. This is our B2. Right? So what happened here? A2 reached to A3, B1 reached to B2. Very good. And same time opposite direction vehicle will also move, and as per the IRC we assume that when A2 reach to A3, C1 will also reach next to the A3 position only. So this is our assumption. These two vehicles will be in a same line at the time of overtaking. Now you will say, sir, how it will be? This is our assumption. When the A2 will reach to A3 position, C1 will also reach to the C3 position, and C is moving on a design speed V only, beta. Okay, so now let's see now again. So let us say now this is called as our S space headway or space gap maintained. This is called as our B. Okay, and this is our called as D3 distance. This is called as D3, and this B plus 2S combinedly called as D2. This combinedly called as D2. So our OSD is the summation of D1 plus D2 plus D3, beta. Okay, I hope so diagram is clear to everyone. Anyone doubt in a diagram? What are you overtaking, beta? What are you overtaking? You are coming like that. You saw the vehicle. You reduce your speed, moving some distance behind that. Change the lane. After changing the lane, move some distance and go to the original lane from where you have started. Okay. Same time we assume that C1 also reached to C2 position in a D3, and I am saying here the time taken by C1 to C2 is T. Same time when the vehicle A2 reached to A3, okay, same time C1 reached to C2, the time is T. Okay, so now OSD is the summation of, why diagram I have given you? Because exam will not ask you to calculate all the distance, beta. Exam will ask you to calculate either D1, either D2, either D3. That's why diagram must be clear in your mind कि which question exam is asking to you. Okay, because if they will ask you complete D1, D2, D3, it will be a little lengthy calculation. Okay, it will be the lengthy calculation. So exam will ask you either D1 or D2 or D3. Okay, it's very rare. They can only the one time the question have come to ask complete OSD. Other than that, the question are coming on some part. Okay, all right. So now come to D1 plus D2 plus D3. So OSD is equals to D1 plus D2 plus D3. What is D1? D1 is the distance when vehicle A1 to A2. Okay, what is D1? Just now we have written D1 is equals to VB into T. Okay, VB into T. What is D2 here? D2 is when A2 to A3, A2 to A3. What is D2 here? A2 to A3. This is calculated as beta B plus 2S. This is calculated as B plus 2S. So what is B here? Anyone can tell me? What is B here? What is B here? What is B here? B is equals to what? B is equals to what? B is equals to here VB into capital T. S is equals to what, beta? 0.7 VB plus L, where L is our wheelbase. L is our wheelbase. If question have given you value, it's okay. If they have not given you, it's considered as 6 meter. Okay, the wheelbase means length of the vehicle indirectly, beta. Wheelbase means length of the direct vehicle. It's a 6 meter. So S is equals to 0.7 VB plus L, and B is equals to this, and T is equals to under root of 4S upon A. A will be acceleration which will be given to you in the question, beta. Okay, S A will be acceleration which will be given to you in the question. Because for doing the overtaking operation, you have to accelerate the vehicle. So A is our acceleration here, beta. Very good, Madhumita. Very good, Narendra. Right? D2. What is D3 here? What is D3? Anyone can tell me? D3 is what? D3 is our when the C1 have been reached to C2. The C vehicle is moving it from the design speed in the opposite direction. It is moving on a design speed. Same time A2 have taken to A3. Same time C1 have taken to C2. So what is the value of D3 value? Very good, Narendra. Very good. It will be very good. It will be V into T beta. It will be here C1 to C2. Here it's a C1 to C2. So here it's a D3. It's a V into T beta. It's the exam. The mostly confusion happen. Which speed you have to consider here, beta? In the exam, mostly confusion happen. Which speed you have to consider? VC. You are writing VC. VC is what, beta? VC is. We assume that here, I told you, we assume that here the vehicle C is moving also on a design speed. Okay, we assume that the vehicle, if the question is not mentioning anything, you assume that it is moving on a design speed. Okay, we assume that it's a design speed, beta. Initially A is also moving on design speed, but once he saw the B, then it reduced the speed to VB, right? Similarly, C1 is moving to C2 with the design speed only. If question have not mentioned anything, you have to consider only the design speed here, beta. Okay. So this is our V into T. So if I say for undivided highway, OSD is equals to, for divided highway OSD is equals to, anyone can tell me? So what I discussed now, I assume that my highway is undivided. So if highway is undivided, what we have taken here? D1 plus D2 plus D3. Yes or no? If highway is undivided, so we are saying here D1 plus D2 plus D3. Okay. So now if highway divided, anyone can tell me what formula will come? What formula will come? A highway divided. If it's a divided, so what formula will come? Very good, Narendra. Very good. It will be only D1 plus D2 beta. It will be only D1 plus D2, because if the highway is divided, so you have a no connection with the opposite vehicle. If highway is divided, you have a no connection with the opposite vehicle. It will be only D1 plus D2. It will be only D1 plus D2. Okay. All right. So this is D1 plus D2, right? And one more thing, if VB is not given, in question, then VB will be equals to V minus 4.5 in meter per second. I always deal with meter per second, so I am writing the formula for the meter per second only. VB is equals to V minus 4.5. If you deal with the kmph, you can write that formula also, no problem, beta. So VB is equals to V minus 4.5 here. VB is equals to V minus 4, V minus 16 you can write. If you are dealing with the kmph, I have no problem, you can deal with that also. Okay. Next is, for OSD calculation, both side drivers are there, beta. So height of driver I here also is assumed as, it's assumed as 1.2 meter. Height of driver I also assumed as 1.2 meter here, beta. Height of driver I here also it's a 1.2 meter, right? Here also it's a 1.2 meter. I hope so, no doubt, right? Okay. Anyone doubt, you can ask me. Very good. Next is length of overtaking zone. Next is length of overtaking zone. So what is the minimum length? What is the minimum length of overtaking zone? Minimum length of overtaking zone and desirable length. Write fast. Desirable length. What is minimum length? Minimum length is very good. It's a thrice of OSD and it's a 5 times of OSD. So now you can ask me one question. So what do you mean by overtaking zone? Sometimes what happens, due to the restriction of land, we cannot provide the OSD throughout the length, beta. We cannot provide the OSD throughout the highway. So what do? In those cases, we provide the overtaking zone, beta. Okay, so in such cases, when the land is restricted, you cannot provide the overtaking side distance. On the complete highway, we provide the overtaking zone. That's a 3 times or 5 times of OSD beta. Right. Next, we have one more note here, which you are saying before, intermediate side distance. Intermediate side distance. Anyone can tell me when do we provide intermediate side distance? Intermediate side distance. So, when do we provide intermediate side distance? Anyone can tell me? No, Guru Prasad. No. When do we provide the intermediate side distance? Anyone can tell me? When? When do we provide intermediate side distance? Anyone can tell me when do we provide? Anyone? Very good, Madhumita. When OSD is not possible, then only we provide beta. Okay. When OSD is not possible to provide. OSD is not possible to provide, then we provide intermediate side distance. The question have come already in the exam. One time the question have not asked you calculate the calculate the ISD. They ask if due to some reason OSD cannot be provided. Okay, so how much side distance we have to provide? That was the question in the exam beta. So how much distance we have to provide? We have to provide equals to intermediate side distance, that is equals to mathematically twice of SSD. The question came in GATE 2020 also. The question came in GATE 2020 also from the ISD. But when do we have to provide? When OSD cannot be provided. So don't link this ISD with the SSD. Okay, don't link ISD with the SSD. What happens sometime, because it's a twice of SSD, you will think like, okay, we have to provide in the place of SSD. No beta, we have to provide when we cannot provide the OSD, then only we have to provide twice of SSD there. Okay. Anyone doubt? Anyone doubt? Anything from your side? Anyone doubt? Anything from your side? Anyone doubt? Alright. So this was the complete side distance characteristics beta. This is complete side distance characteristics. No question will be missed if you know this thing. No question will be missed if you know these concept only. But thing is, don't mug ISD twice of SSD. You must know what is the meaning of that. Why we are providing, that is also important, because the gate will play the game. They will not ask you directly. They will say you how much we have. If land is restricted, so how much SSD can be provided if OSD cannot be provided. Okay, so it's a side distance that we have to take care in the mind bit. Okay, all right. So this is the complete our intermediate side distance, stopping side distance, overtaking side distance, and the headlight side distance. Okay, sorry, I forgot. Priority intersection. One time the question have come. But Guru Prasad, if I say before the gate exam, if you say before the gate exam, the question asked in the exam, nobody taught the priority intersection. Okay, nobody teach what is the priority intersection. Okay, only when the gate started, gate asked the question on this, then you will see the notes on this. Other than that, that's a very detailed topic which we will generally study in a masters. But let's see what is that. It's a very simple. One time the question have come, if any major road is there, and here some minor road is connected with that. Here some minor road is connected with that. Okay, this is our major road. This is our major road, and this is our minor road. This is our minor road. Okay, yeah, very good, Madhumita. Okay, so you can see here, it will make a one triangle here. Okay, it will make a one triangle here. So question may ask you in the exam, what will be side of this triangle? What will be side of this triangle? So the side of this triangle is according to the IRC. So that's why I said the data questions you may leave beta, because whenever the thing will come, you have to remember the data now. It will become difficult for you. Okay, it will become difficult for you. So these questions are, if you know the data, then you can solve. If you don't know the data, you cannot apply the concept here. Right? So according to the IRC, if this is the case, here you have to provide 15 meter on a minor road, and on a major road, you have to provide V into 8 seconds. It's a V into T. So time is considered as here 8 seconds beta. V is here design speed, and here the dimension is fixed, that is a 15 meter on the minor road beta. Okay, so this is called as our priority intersection. This is called as our priority intersection. Okay. When one minor road is connected with the major road, you will see this situation is very normally you can see in the roads. Okay, so what we have to do? How much distance we have to, how much side distance we have to provide here? 15 meter on a minor road. On a major road, it should be V into 8. Okay. Any doubt? Anything else in this one? If I miss, just you can remind me. Or if you have a doubt, you can ask me. Anyone, any doubt? Or you can ask me if you have. Anyone? 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 Clear? Everything clear? Alright. Next, I am moving to the horizontal alignment. Next, I am moving to the horizontal alignment now. Next, I am moving to the horizontal alignment. Here you know what we are going to study. Here we study about the super elevation part, right? Here we studied about the super elevation part and the transition curve and setback distance. So these 3-4 things are there which are going to study in a horizontal alignment. So first thing is, here we study about the super elevation. Why do we need to provide the super elevation? We have a two case. One is overturning. Second one is, why do we provide the super elevation? One is overturning, other one is, why do we provide the super elevation? One is overturning, other one is to avoid the very good skidding. Right? So I hope so all of you know, to avoid overturning. What is the condition? To avoid skidding. What is the condition? Just tell me fast. I am not going to draw the diagrams again. And to avoid both means overturning and skidding. What is the condition? Tell me fast. What is the condition to avoid the overturning? What is the condition? Let me consider. This is my, let us say we have one vehicle here. Okay, and width of the vehicle is B, and height of centroid is here H, and centrifugal force is, let us say this is inner side, this is outer side. So centrifugal force will be act on outer side P. Okay, and the weight is there, self weight is acting downward W. So anyone can tell me what is the condition for to avoid the overturning here? The condition for overturning is beta, the P by W must be less than B by 2H. P by W must be less than B by 2H. This is the condition to avoid the overturning. Okay, and what is P by W? This P by W is called as centrifugal ratio, or this is also called as impact factor. Okay, this is also called as impact factor. Very good. This is the, Manumita, what you are saying? Yeah, very good. P by W must be less than B by 2, Manumita. It's not a greater than. If it will be greater than, it will overturn beta. Okay, it must be less than. And can you tell me what is the condition for skidding? Everyone tell me fast. For skidding, P by W must be less than F. What is F here? Beta? F is here. F is equals to what? F is equals to what? What is F here? What is F? F is what? F is equals to what? Everyone tell me fast. What is F? F is equals to here coefficient of lateral friction, not longitudinal. Longitudinal is over in a stopping side distance or overtaking side distance. Here the friction is now lateral friction beta. Here the friction is coefficient of lateral friction. The value is considered as 0.15 according to the IRC. The value is 0.15. Now anyone can tell me, to avoid the both overturning and skidding, what is the condition? What is the condition? If we have to avoid both overturning and the skidding, what is the condition? P by W must be less than P by W must be less than minimum of B by 2H or F beta. Okay, so we have to calculate both. Whatever minimum is coming, so P by W must be less than that to avoid the both at the same time. Okay, if you avoid the both overturning and skidding at the same time, so what should be the condition here? The condition will be P by W must be less than minimum of B by 2H or F. What is P here? What is P here? What is P here? P. What is P here? P. P is equals to centrifugal force. P is our centrifugal force and W is our weight of vehicle. W is our weight of vehicle beta. W is our weight of vehicle, right? So this is the condition. So these are the two regions. That's why we provide the super elevation on the highway. If super elevation will not be provided, the vehicle may be overturned or the skid. So these are the two things we have to provide the super elevation beta. Okay, so now I am moving to the super elevation. Super elevation is also very good, very good. Narendra, it's not pull, it's a P is our centrifugal force. Okay, P is our centrifugal force, right? So now I am saying here super elevation. Now I am saying here super elevation, which is also called as cant. Maybe you know in a railway you use the word cant here. Okay, this is also known as banking. This is also known as banking beta. Okay, P by, this is also called as cant or banking. So now I hope so you know, here you derive one equation. Here you derive one equation. What the, for a particular vehicle, this is very important concept. For a particular vehicle, the formula is E plus F is equals to V square upon 127R. E plus F is equals to V square upon 127R beta. Okay, this, if you derive this equation, here also you will find P by W is equals to E plus F beta. P by W is equals to E plus F. If you know the derivation, you will find this thing. We find the relationship P by W, then we convert into, it's a E plus F. So E plus F is also equals to P by W only. Okay, yeah, very good, very good. Now here one thing, open the eyes, ear very carefully. Yeah, I will come to that. Open the eyes and ear very carefully. E plus F is equals to V square upon 127R. E is here our, E is our here super elevation. E is here super elevation. E is here super elevation and R is our radius of horizontal curve. And you know one thing, I am making capital V, speed we have to put in a kmph. V is in our kmph here beta. V is here in kmph here. Now this is for a particular vehicle. Sometime what happen in the exam, question they will ask you, find the super elevation for a particular vehicle, the value come, let us say 0.09. The what comes in your mind, for a plane condition, it's a 0.07 and you will mark the answer 0.07. Beta, when you are applying this formula, no need to compare with the maximum value of super elevation. When you are applying this formula, then no need to compare with 0.07, 0.10 or 0.04. This is for the single vehicle or particular vehicle. So don't compare the result you are getting from this with the standard value. This is the first mistake possible while applying this. This is for a particular vehicle or a single vehicle beta. Okay, so E plus F is equals to V square upon 127R beta. Okay. Now here one question also arise sometime. What is the question arise here? If I draw the diagram here, you can see if we have one without the super elevation, this is my pavement, this is my inner side and this is my outer side. After super elevation, what happened? After super elevation, it will be like that, it will be like that, and this will be my super elevation E. Let us say this is our width of the pavement W and this height is E. So exam may ask you what is the, how much rise is there on the outer side. So what you will say here, it's like a tan theta, E is equals to E upon W beta. E is equals to E upon W. So maybe exam may ask you how much rise you have to do. They will not ask you what is the super elevation value, they will ask you what is the rise on outer side. So if you know the super elevation value, very good, Niket, very good. If you know the super elevation value, you can calculate E upon W here beta. It's like a tan theta. It's like a tan theta, right? It's like a tan theta. Tan theta is equals to E upon W beta. Okay. So anyone doubt up to now? Anyone doubt up to now? I hope so. You know one more term here. I'm writing the note now. I'm writing the note here. What is note? Note is here equilibrium super elevation. Equilibrium super elevation. Anyone can tell me what is equilibrium super elevation? What is equilibrium super elevation? Anyone can tell me? What is equilibrium super elevation? Anyone can tell me? What is equilibrium super elevation? Anyone tell me beta fast? What is equilibrium super elevation? Anyone can tell? Anyone? Equilibrium super elevation means beta. Here you can see I consider the one vehicle. So the vehicle have a two tires here. One tire is here. One tire is here. Equilibrium super. Very good, Madhumita. You are writing correct. You are deleting. Equilibrium super elevation means, yeah, very good. It means what? Pressure or reaction is same on both tires beta. Pressure or reaction is same on both tires. Okay, or reaction is same on a both tire. So what we do in we know the equation E plus F is equals to V square by 127 R. For equilibrium, what we do, we make this F 0. So E equilibrium is calculated as V square by 127 R directly. Okay, very good, Madhumita. It's considered, no, Narendra, that is different thing beta. That is different thing, we'll come to that. So E equilibrium is V square by 127 R beta. It's a V square by 127 R, only F will be equals to 0. Okay, it will be equals to 0 beta. Anyone doubt? This is called as the question may come in this because up to now no question have come from this concept. Equilibrium super elevation have been not asked in a gate up to now. IS have been asked, the gate exam have not asked. So V square by 127 R. They will not ask you calculate equilibrium super elevation. They will ask you if the reaction on both the tires have become equal. So what is the super elevation? It means beta F is 0 there. F is 0 here. It's a V square by 127 R. Anyone doubt? Anyone doubt? Anyone doubt here? Anyone doubt? All clear? All clear. Next we have design super elevation beta. Next we have design super elevation. Next we have design super elevation. Next we have design super elevation. You know the equation. What do you know? You know E plus F is equals to V square by 127 R. Design means beta. We are now design means what? Now the vehicle is not particular. Mixed traffic is moving. It means the traffic is mixed. It means the traffic is mixed traffic condition. Design, because while you are designing the highway, it means the vehicle are mixed. It can be any class of vehicle which is moving. So what we do? What we do for mixed super elevation or design super elevation? We say here beta for mixed super elevation F is 0 and E will becomes to E design and V will be, anyone can tell, V will be reduced to 0.75 V as per the IRC. The V will be reduced to 0.75 V. So if F is 0, E is this. So E design formula will convert it V square by 225 R. The formula will convert V square by 225 R. Can you tell me the value of ED is lying between, the value of ED is lying between E max and E minimum. Okay, can you tell me what is E minimum? E minimum is equals to what? E minimum is equals to what? Anyone can tell me first? E minimum is equals to what? E minimum is what, beta? E minimum is how much? E minimum is equals to what I told you. That's why I said to you starting to remember two values there. E minimum is equals to what? E minimum is equals to what? Anyone? E minimum is equals to what? E minimum is equals to beta camber value. E minimum is equals to camber. How much camber is there? That is equals to E minimum. So E minimum is equals to camber value, and E maximum is depend upon the different terrain. E maximum it depend upon different terrain. So it's for a plain, rolling or hilly with snow. Hilly with snow. The value is here 0.07. For hilly without snow, the value is here 0.10. The value is here 0.10. Okay, so 0.07 and 0.10, that I was saying to you that time. Okay, that I was saying to you there, beta, कि don't compare these results while applying this formula. While applying this formula, don't compare these results, beta. These results will be only comparable when you are talking about the design super elevation. Okay, what is camber? I told you already, right? Camber, I told you, right? 1.7% for light rainfall and 2% for heavy rainfall. 2% for heavy rainfall and 1.7% for light rainfall, beta. So E design will be always in between E minimum to E maximum. Anyone, any doubt you can ask me? Anyone, any doubt you can ask me? Anyone, any doubt you can ask me, beta? Anyone, any doubt? Anyone, any doubt? Anyone, any doubt? All right. So now this is our E minimum, E maximum here, beta. E minimum, E maximum is here. Now one special case is there. The question have come already. Condition for stopped vehicle. Condition for stopped vehicle. Condition for stopped vehicle should not slide downward. This is the gate question. What question is saying? Question is saying if any vehicle was here, okay, this is a stopped vehicle. So what is the condition so that this vehicle should not slide downward? Anyone can tell me? Let us say super elevation is E here and lateral coefficient is F here. Okay, so what is the condition for this? The stopped vehicle should not slide downward. What is the condition for this? The question have come already in the exam. The question have already come in the exam. What is the condition for this? The stopped vehicle should not slide downward or inward here. Okay. It's an inner side, so you may say inner because it's an inner side. So stopped vehicle, if any vehicle is stopped on the curve, it should not slide. Very good, Narendra. Very good, very good, very good. It is the condition is here. E must be less than or equals to coefficient of lateral friction, beta. E must be less than coefficient of lateral friction. This is the condition. Why? Because P will become 0 here. Okay. P will become 0 in this case because the vehicle is stopped. So E, very good, Mayank. No, you are writing opposite, Mayank. It's a E must be less than equals to F. It should not be greater than. Okay. So this question may come in the exam. Already have come 2 times in a gate. Okay. Already have come 2 times in a gate. E must be less than equals to F, beta. Okay. Alright. Now write some note again. I hope so you know. So I am writing 3 things in the front of you. Ruling minimum radius. Ruling minimum radius. Absolute minimum radius. And third one is radius beyond which no super elevation is required. Beyond which no super elevation is required. Radius beyond which no super elevation is required. Okay. So three things are there here. Okay. So three things are here. Super elevation provided with respect to central edge. The question will mention, Guru Prasad, this thing. It's about the center. If they will say center, we have to rotate the diagram from the center, beta. Okay. If they will say if there's its center, so means sometimes you measure from the center, sometimes we measure from the inner side. If they will say from the center, so you will calculate, you will rotate the diagram at a center, beta. You will rotate the diagram at a center and you can write here. Okay. Alright. So anyone can tell me what is the formula for these three radius? Ruling minimum radius or absolute minimum radius, radius beyond which no super elevation required. Anyone? 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 What is the formula for these three radius? What is the formula for these three radius? Anyone? Anyone? Very good. Here the formula is same, beta. You know E plus F is equals to V square by 127 R. The thing is only what? Only thing is here, the radius is here, you can say here, radius will be equals to V square upon 127 E plus F, beta. Ruling means what? Ruling means design, beta. Ruling means design. Just a second. Studio team, please check once the connection. Please check the connection. Okay. The ruling minimum radius is, beta, R is equals to V square upon 127 E plus F. So here you will use V design, beta. Here you will use V design, beta. Okay. Here you will use. Now it's okay or not? Now it's okay or not? Now is it okay? Yes or no? Now I'm audible. Now it's okay, Nikhit. Nikhit, now it's okay. I can confirm. Am I audible? Now it's audible, Bhagisri. Now it's okay. All right. So what we are discussing now? We are discussing the different radius here. Okay. So we have a 3 radius: ruling minimum radius, absolute minimum radius, and radius beyond which no super elevation is required, beta. So ruling minimum radius, the formula is here. Okay, v square upon 127 e plus f. Here what will we do? We will put here design speed, beta. And design speed. Can you tell me design speed depends upon what? Design speed depends upon what? Anyone can tell me? Design speed depends upon what parameters? What factors? Design speed depends upon what factors? Design speed depends upon what factors, beta? It depends upon 2 factors. One is the topography, and second one is type of road, beta, or type of road. Okay, so 2 things are there. On that design speed depend. Type of road, it means NH is there, SH is there, expressway is there, MDR is there, ODR is there. Okay. Similarly, absolute minimum radius is calculated based on minimum speed, beta. Every highway have a one design speed, one minimum speed. So absolute minimum radius is calculated based on the minimum speed. Anyone can tell radius beyond which no super elevation required. One time the question have come on this. The radius beyond which no super elevation is required. What is the formula for this? What is the formula for this? What is the formula for this here, beta? What is the formula for this? Radius beyond which no super elevation is required. That's very important, beta. Here the radius is equals to what? V square upon 225 into E minimum, where E minimum is equals to camber value. E minimum is equals to camber value. So R is equals to V square upon 225 into E minimum. Very good, Manumita. Okay, it's a very good. So this question may come in the exam. R is equals to V square upon 225 into E minimum, where E minimum is equals to, you know, that is equals to camber, beta. Okay, so these are the different types of radius. Maybe the exam, if you use the word absolute minimum radius, it means that radius will be calculated based on minimum speed. If ruling minimum radius, it will be calculated based on the design speed, beta. Okay, so this is the complete about the super elevation. Next we have extra widening. I hope so all of you know extra widening. Next topic we have extra widening. I hope so all of you know why do we provide extra widening? Why do we provide extra widening? According to IRC considers the 2 factors here. One is the off tracking. Okay, one is the off tracking. Second one, IRC have considered psychological tendency, beta. Second one, IRC have considered psychological factors. Okay, so extra widening. I hope so all of you know the formula. This is a mechanical extra widening plus psychological extra widening. This is calculated as NL square by 2R. This is calculated as V upon 9.5 root R. Right? Where N is equals to what? Where N is equals to number of lanes. N is equals to number of lane. L is equals to wheelbase, which I already told you in OSD. If it's not given, it will be considered as 6 meter. V is our design speed. Okay, and R is our radius. Which radius? It's a ruling radius, beta. Okay, it is our ruling radius. Which radius? Ruling radius, beta. It means design radius here, right? And I hope so all of you know this L square by 2R is called as off tracking. This L square by 2R is called as off tracking, beta. Okay, n is number of lanes, n is our number of lane, L is our wheelbase, V is our design speed. Okay, so this is very important. It may come in, it have been come various time in the exam. Extra widening. So NL square by 2R plus V upon 9.5 root R. This is called a mechanical extra widening. This is called a psychological extra widening. Very good, Madhumita. Okay. So this is the complete about the extra widening, beta. Next we have transition curve. Next we have transition curve. Next we have transition curve. Why do we provide transition curve, or what is transition curve? Why do we provide transition curve, or what is transition curve? Why do we provide transition curve, or what is transition curve? Anyone? What is the use of transition curve, or what is the transition curve? In this one, radius is varies from infinite to r beta. What happened from a straight line to circular curve? We provide a one curve in between that is called a transition curve. That is called a transition curve. Okay. So why? First thing is, for the comfortable, we provide this. For introducing the super elevation, we provide this. For aesthetic appearance, we provide this. To avoid the jerk, we provide this beta. Very good, Guru Prasad. It's a infinity to r. Okay. So now the length of transition curve is calculated based on three criteria. Just write all of you in the chat box. What are the criteria? The length of the transition curve is calculated based on three criteria. All of you write what are the criteria. Length of transition curve. I am writing here, this is for comfort, for avoid the sudden jerk, and to introduce the super elevation, Okay, so now length of transition curve is calculated based on three criteria. Length of transition curve is calculated based three criteria. One is very good. One is comfort condition. Second one is what? Second one is what, beta? Based on introduction of super elevation. Third one is our empirical formula. Third one we have empirical formula. One thing you tell me, what is the shape of transition curve we provide? What is the shape of transition curve we provide, beta? Which shape of transition curve we provide? We provide here. Which shape we provide here of transition curve? We provide spiral. We provide spiral shape of the transition curve. Okay, the ideal shape of the transition curve is spiral. The ideal shape is spiral. Now come to the formula for the length of transition curve. So what is the formula for based on comfort condition? The formula is V cube upon CR beta. Okay, V cube upon CR. This is also called as based on jerk. Okay, this is also called as based on jerk, right? Because C is here what? C is here jerk beta. C is here jerk, which is dA by dt. This is also 80 upon 75 plus V. This is calculated as 80 upon 75 plus V cube upon CR beta. Okay, you will get here in meter per second cube. This is dA by dt. dA by dt means rate of change of acceleration. Jerk is rate of change of acceleration beta. It's a dA by dt. So 80 upon 75 plus V. This is our LS. Now based on introduction of super elevation, I hope so all of you know the formula is here. LS is equals to. Now here two cases are there. Pavement is rotated about inner edge or pavement is rotated about center. So now I am writing for inner edge. If it's about inner edge, so LS is equals to N into E design W plus WE. Now if it's a center, the formula will be N into ED into W plus WE by 2. The formula is N into ED into W plus WE by 2. What is N here? What is N here? Anyone can tell me? What is N here? What is N here, beta? N is our rate of introduction of super elevation. Rate of introduction of super elevation, beta. Rate of introduction of super elevation. rate of introduction of super elevation. So what is the value of n for the different category? Anyone can tell me? N depends upon topography beta. Okay, n depends upon topography. So can you tell me what is the value of n for plain or rolling terrain? What is the value of n for plain and rolling terrain? What is the value of n for plain and rolling terrain? What is the value of n for plain and rolling terrain? Very good, very good. N is now here, n is equals to 150 for plain on rolling terrain. For hilly terrain, how much? For hilly terrain, how much? For hilly terrain, how much? For hilly terrain, for hilly, how much? For hilly, how much? It's a 60. For built up areas, how much? For built up area, how much? For built up area, it's how much? It's a, for built up area, how much? It's a 100 beta. Okay, for built up area, it's a 100 beta. Okay, so area is built up area, not 90, it's a 100 beta. Okay, it's a 100 for a built up area, right? Now come to third one, empirical formula. So now LS is equals to 2.7 V square by R. The formula is LS is equals to V square by R. This one is for plain and rolling terrain, and this is for our hilly terrain. This is for our hilly terrain. Up to now the gate have not asked. It's a 100. Okay, it's a 100. Okay, up to now no question have come in that all three criteria have been asked in a gate beta. Up to now no question have come in that all the criteria have been asked. So in the gate what will we do? What they will do? They can ask you any specific. Empirical, it's very rare. I don't think so they will ask. They can ask you either the comfort condition or introduction of super elevation beta. Okay, so just remember the formula. If they ask you all the things, what will the final answer? The final answer will be maximum of all three. The final answer will be maximum of all three beta. Okay, maximum of all three will be the final answer if they will ask you the calculate the length of transition curve. So you have to calculate based on all the criteria and maximum of all, that will be your final answer beta. Okay, all right. Any doubt up to now? Any doubt up to now? Any doubt up to now? Anything from your side? Anyone, any doubt? Anyone, any doubt? Everything clear? Everything clear? Next topic is setback distance beta. Next topic is setback distance. Next topic is setback distance. I hope so you know in a setback distance we have a two cases. One is when length of the curve is greater than side distance. Second case is when length of the curve is less than side distance. We have a two case. LC is here length of the curve, okay, which is greater than side distance, and second case is length of the curve less than side distance. Now side distance can be here SSD, it can be OSD, it can be ISD. Okay, anything can be possible here. Side distance, it can be SSD, OSD, ISD, whatever is there, it can be anything here beta. So case is this. Now in this case I am writing the general formula. M is equals to, the formula is R minus N minus 1 into D into 1 minus, anyone can tell me? I am writing general formula. I am not putting the value of specific number of lane. The formula is this: R minus N minus 1 into D, 1 minus cos alpha by 2, where alpha by 2 can be calculated as S upon 2 R minus N minus 1 into D into 180 by pi beta. Now you will say, sir, we know the formula R minus R cos alpha by 2. That you know for single lane beta. Put the value of N here 1. Put the value of N here 1. What it will be? Put the value of N value here 1. It will become R minus R cos alpha by 2 only. Okay. So this is R minus N minus 1 into D into 1 minus cos alpha by 2. This is the formula. This is the formula. This is the formula when number of lanes are N. Maybe you know the formula. I am writing the general formula beta. That can be put anything here. Okay. If your number of lanes are 2, you put here 2. If number of lanes are 1, put here 1. Okay. And what is D here? What is D here? What is D here? Setback distance always calculated from center of inner lane beta. Always calculated from center of inner lane. So D, I hope so all of you know, if this is my single lane, this is my single lane, this will be center line, this will be our center line, this is V, W, this will be our D beta. Okay, this will be our D here. So D is the distance between center of inner lane to this beta. Center of inner lane to center of, this is our center of inner lane. This is our center of inner lane. Center of inner lane to the, Madhumita, I am not getting you 0. What you are saying 0? What is 0 beta? What is 0 here? So D is here. Let us say if width is 3.75 meter. So D will be 3.75 by 2. Okay. If it's a 4 lane, it's 2 lanes are there. Let us say 2 lanes are there. On the curve 2 lanes are there. This is the center divider line. This is divider. Okay. And so what will be D value here? The D will be 0 for single lane. Yeah. Okay. So what will be D value here? D value will be this beta. D value will be this for a 2 lane. For 2 lane. For 2 lane, D value will be this. Okay. D value will be this for 2 lane beta. Okay. This is our 2 lane. This is our first lane. This is our second lane. Okay. So what will you do? The distance between center of inner lane to the outer side. Okay. Center of inner lane to the outer side. This is our D value here. Okay. So if I say total width is W, here W will be equals to 4 times D. So D will be equals to W by 4. D will be equals to W by 4 in the case of 2 lane beta. Okay. Second case is when LC is less than side distance. I hope so all of you know the formula here again. Anyone know the formula here? The formula is here R minus N minus 1 into D into 1 minus cos alpha by 2. Whatever you have written same, one more term will add here, S minus LC by 2, S minus LC by 2 sin alpha by 2. Up to now, the second case have been not asked in the exam. Okay, up to now, second case have been not asked in the exam. Only the question have come from the first case only. Okay, only the question have come from the first case only. R minus N minus 1 into D into 1 minus cos alpha by 2 plus S minus LC by 2. I will cover everything, Guru Prasant. I will cover everything beta. R minus N minus 1 into D, 1 minus cos alpha by 2 plus S minus LC by 2 into sin alpha by 2. This is the formula for setback distance in the case of length of the curve less than side distance. But here alpha by 2 will be equals to, what will be there? Here it's a S. Now what is less here? LC. Here the formula will be LC upon 2 into R minus N minus 1 into D into 180 upon pi. Okay, here it will be 180 upon pi. It will be multiplied like that beta. Okay, here it will be multiplied like that. Whatever is less, that will be in the numerator for the alpha beta. Here S was less, so S is here. Here LC is less, LC is here in a center of the curve to the center of inner line. Center of the curve to the center. Beta, center of the curve means you are saying this, or center of inner line this. You can say this also, it's the same thing beta. It's the same thing. Okay, Nikit, this is same thing, only what you are saying. You are saying this D, I am saying this D beta. Okay. Okay. What if I am saying to you, na, D will be directly, you can say here, D will be equals to W by 2N beta. D will be equals to W by 2N. Okay. Just put N here, number of lane, you will get that D value. D is W by 2N here directly. If you don't understand what is D exactly here, you can remember D is equals to W by 2N. Okay, setback distance always calculated from center of the inner lane. Okay, all calculated from center of inner lane beta. It is always calculated from center of inner lane. So D is equals to W by 2N. You just remember, it will be done. Okay, For 2 lane, it will be W by 4, which I told you already. For single lane, it will be W by 2. Okay. Anyone doubt? Anyone doubt? The question may come from first part. Second case is very rare in the exam because it will be lengthy calculation beta. Anyone doubt up to now? Anyone doubt up to now? Anyone doubt? Next, one small topic is there. I hope so all of you know, that is the curve resistance. Next topic we have curve resistance. Next topic we have curve resistance. Anyone know? Curve resistance. Curve resistance. The curve resistance is T minus T cos alpha. Okay, T minus T cos alpha, and this will be calculated for rear driven vehicle only. Okay, this will be for rear driven vehicle only. For front driven vehicle, the front driven vehicle CR will be 0. There will be no curve resistance beta. There will be no curve resistance in a front driven vehicle. Only the rear wheel driven vehicle have a curve resistance problem. Okay. For front wheel, it will be 0. For rear wheel, it will be T minus T cos alpha, where alpha is our turning angle. Where alpha is our turning angle. Where alpha is our turning angle. Okay. Alpha is our turning angle beta. So up to now, no question have come from this. Up to now, no question have come from this. T minus T cos alpha. Okay. So T minus T cos alpha is here. Alpha is our turning angle. Means how much angle you are turning your steering here. Okay. How much angle you are turning, that is our alpha here. Anyone doubt up to now? Anyone doubt up to now? Anything from your side beta? Anything from your side? Anything from your side? Anyone? Anything from your side? Alright. So this was the completely all about the horizontal alignment beta. Okay. This is the completely about the horizontal alignment. Okay. We have not missed any single thing in a horizontal alignment. Last topic of this one is vertical alignment. Last topic of first chapter is vertical alignment, which is also very much important for the GATE exam. Last is vertical alignment. In that first we studied about the different types of gradient. In that first we studied about type of gradient. Everyone write what are the types of gradient? Everyone write what are the types of gradient first. What are the types of gradient you know? Everyone write first. What are the types of gradient you know? First everyone write. What are the types of gradient you know? Everyone write first. What are the types of gradient you know? Everyone write it first. A type of gradient I am asking, Guru. I am not asking type of curve. What are the types of gradient you know here? What are the types of gradient you know here, that I am asking? Very good, Madhumita. Here the gradient first one is ruling gradient. That is also called design gradient, you can say here. Next one we have limiting gradient. Next one we have exceptional gradient. Okay, and last one we have minimum. Last one we have minimum. Which gradient is more steeper? Not rise and fall. Okay. Which gradient is more steeper here? Which gradient is more steeper? Or which is less steeper? Which is more steeper in this? If I say here, this is my rule RG. RG means ruling gradient. LG means limiting gradient. EG means our exceptional gradient. MG is our minimum gradient. I want to write the increasing order of this. I want to write increasing order of this. All of you write increasing order of this. All of you write the increasing order of this. Which is more deeper or more steeper? Which is more steeper? Which is more steeper? Here if I write the order here beta, exceptional gradient is more steeper compared to limiting gradient, is more steeper compared to ruling gradient, is more steeper compared to minimum gradient beta. Minimum gradient only with exceptional, very good. Exceptional is very much steeper. Okay, out of that, very good. Exceptional, limiting, ruling, minimum. Minimum gradient is just provided to ensure that for the drainage part. Okay, minimum gradient is provided on the vertical curves for the drainage purpose, right? So I am writing here only the values of these gradient for plane and rolling terrain. It may be important. Okay, so ruling gradient, limiting gradient, exceptional gradient. So anyone know what the value of ruling gradient or limiting gradient or exceptional gradient for the plane and rolling terrain? Anyone know? Anyone know the values here? What is the value here, beta, for the ruling gradient for plane terrain? Anyone know? For the plane and rolling terrain, what is the value of these gradients? Anyone know? The value is here. The value is here 3.3%. Here the value is 5%. Anyone know value? Here the value is 6.7% beta. Okay. Here the value is 6.7%. Just remember this 3.3% value. It may be helpful for the exam. Okay. Just remember this value 3.3%. Okay. It will be 3.3%. Just remember this value. Okay. Also there is one relationship which you need to remember. Ruling gradient is equals to twice of camber. Okay. Ruling gradient is equals to twice of camber. That also remember beta. Okay. One time IAS exam have been asked this question. IAS have been asked this question. Ruling gradient is equals to twice of camber. Okay. So one time IAS have been asked. Ruling gradient is equals to twice of camber. Anyone doubt? Anyone doubt? Now I am moving to the curves part. First one we have summit curve. Now how the summit curve will be? I hope so all of you know. Summit curve is like that beta. Summit curve is like that. It means if I draw the tangent on the first and the last point, if tangent if tangent is meeting above, this is called as summit curve. Anyone can tell me what is the first point of the curve is known as? The first point of the curve is known as what? The first point is known as what? The starting point is known as what? The starting point of the curve is known as what? Starting point is known as PVC, point of vertical curve beta. The intersection point is known as PVI, point of vertical intersection, or VPC. Anything you can write, Madhumita. PVC or VPC. And last point is known as PVT, point of vertical tangency. Okay. PVI, point of vertical intersection, PVC and PVT. And here the topmost point of the curve is known as summit point. The topmost point is known as summit point beta. The topmost point is known as summit point here. Okay. The topmost point is known as summit point. Okay. So now let us say the length of the curve is here L. So now some things are there, some formulas are there about related to this, that we will write now. First tell me what is the ideal shape of summit curve. Anyone tell me what is the ideal shape of summit curve? I am saying, let us say here gradient is plus n1 and here the gradient is minus n2%. Okay. First tell me what is the ideal shape of summit curve. What is the ideal shape? Ideal shape is, that is the shape which you provide beta. Ideal shape for summit curve is circular. Okay. Ideal shape is circular. According to IRC, practically we provide square parabola. Okay. We provide square parabola. Okay. Ideal shape is circular, but we provide 2-degree parabola or square parabola beta. Okay. So now what is the equation of summit curve? Anyone tell me? What is the equation of summit curve? Equation of summit curve is what? What is the equation of summit curve? Y is equals to n by 12 into x square. Y is equals to n by 12 into x square. What is y here? What is y here? Anyone can tell me? What is y here? What is y here, beta? What is y here? Y. What is y here? Y which distance here? My question is this. No, Bhagyasri. That you are talking length of the curve. I am not going to that. I am asking equation of summit curve. Equation of summit curve is n by 12 into x square. So anyone can tell me what is y here? Which distance is y? Which distance is y here? The y distance is beta above the curve. Okay, this distance is y. This distance is y. Whatever x value you will put, you will not get this y. Y is this value here, beta. That is the most important thing in this equation. That is the most important thing in this equation. Y distance is this distance. Okay, y is the distance which is above the curve. If you put the x value, this x value you will put, you will get this y value, not this y value. Okay, so y is equals to n by 12 into x square, right? Now I am asking to you here, location of summit point. Location of summit point. Location of summit point, anyone can tell? If length of the curve is L, so what is the location of summit point? What is the location of summit point? Summit point is topmost point of the curve, right? So what is the location of summit point, beta? What is the location of summit point? Anyone? What is the location of summit point? Madhumita, Guru Prasant. What is the location of summit point? If length of the curve is L, the location of summit point is here L by 2. The location of summit point is here L by 2. It means, sorry, location of, not summit point, location of PVI. Sorry, I got confused. Location of PVI. Location of PVI is always L by 2. Okay, location of PVI is always L by 2. It means the PVI curve, this line will always divide the curve into two equal halves, beta. Okay, if you draw the perpendicular from the PVI, it will divide the curve always into a two equal halves. That's a L by 2, L by 2. Now if I ask you location of summit point. Location of summit point. The location of summit point is n1 into L upon n. This is from left side, and n2 into L upon n. This is from right side. This is from right side, beta. Okay, n1 into L upon L. This is from left side. n2 into L upon n. This is from right side. Okay, n1 L upon n, n2 L upon n. Right. Now next one is radius of summit curve. Next one is radius of summit curve. This have been not asked up to now in the exam. What is the radius of summit curve? R. Anyone can tell me formula? What is the radius of summit curve formula? What is the radius of summit curve formula? Anyone can tell? What is the radius of? Very good. The formula is here L upon n. What is n here? N is here our deviation angle. Okay, n is our here deviation angle, which can be calculated as n1 minus n2. Okay, which can be calculated as n1 minus n2. R is equals to L by n. So this is the complete about the summit curve. Thing is here, this equation, why it's important, beta? The question may ask you about on this equation in the exam. Okay, the question may come based on this equation. Okay, question may ask you the distance between PVI and this point. They may ask you the distance between this and this point. So what you have to do? Very careful, beta. Y is equals to n by 12x square, where y is the distance which is above the curve, which is not here. This is not y. Y is above the curve, beta. Okay, whatever x value you will put, corresponding y will be above the curve, not below the curve. And one more thing I forgot to tell, n will be always here, n will be always here positive. N value will be always positive. N is what? N1 minus N2. N is what? N1 minus N2. That will be always positive here. Okay. Now come to the length of summit curve. Now come to length of summit curve. Now Bhagyasri, you can tell your formulas. Length of summit curve. Here also we assume that we have a, here what will we do? Length of summit curve. Here what will we do? Length of summit curve. Here again we take a two case beta. When length is greater than side distance. Second case when length is less than side distance. Again we have two cases. Very good. I don't know, Nishant. When length is greater than side distance, when length is less than side distance. Okay, greater than side, then less than. Now I hope so you know the formula here. Side distance can be SSD, it can be OSD. It can be SSD, OSD. The general formula is here ns square upon 2 into under root of h1 plus under root of h2 square. Okay, now if you say for SSD, I told you already, for SSD we assume h1 is 1.2 meter, h2 is equals to 0.15 meter. For OSD h1 is equals to 1.2 meter, h2 is also equals to 1.2 meter. Right? So if you put the value here for SSD, you will get the formula here ns square by 4.4. Here you will get the formula ns square by 9.6 beta. Okay, ns square by 4.4. Yeah, very good. ns square by 9.6. Now here L is greater than SD. So SD means side distance. Here again, when length is less than SSD or OSD, the formula anyone can tell. The formula, this formula will change. L is equals to 2n minus 2s upon, anyone can tell? What is the formula here? Anyone can tell? The formula will be here 2n minus 2 into under root of h1 plus h2 whole square divided by s beta. So if you put the all value here again, the formula will come for SSD. Formula will be L is equals to 2s minus 4.4 upon n. Sorry, I have written here. 1 second. Here it will be s. Here it will be n. So 2s minus 4.4 upon n, and here it will be 4. OSD, the formula will be 2s minus 9.6 upon n. 2s minus 4.4 upon n, 2s minus 9. L is equals to SD beta. If there you have to provide no need to provide the curve, it means only the side distance is sufficient, Nishant. Okay. If this is the case is coming here, it means no need to provide the curve there, only side distance will be sufficient. If the both criteria will not be satisfied, it means no need to provide the curve there, only you have to provide the distance equals to side distance there. Okay. I hope so all of you know the numerical. What we do in the numerical, first we take first case. If first case will not satisfy, we will go to the second case. Now here thing is, what game can be played in the exam? The value of h1, h2 may be given something else beta. Okay, h1, h2 value will be given something else. So be careful in the exam. h1, h2 1.2 meter, 0.15 meter. If it's there, then it's a 4.4 or 9.6 beta. Okay. If it's not there, the formula may be changed. So you remember this formula also if possible. Okay, up to now the gate have not played that much game in the exam, but it can be played beta. Okay, it can be played. Okay, it can be played. So then you have to be very careful here. It will be ns square by 4.4, 9.6 only when h1, h2 are these values beta. Okay, anyone doubt? So this is the complete about the summit curve. This is complete about the summit curve. Next we have valley curve. What the shape of valley curve we provide? What the shape of valley curve we provide? Anyone tell me? What the shape of valley curve? You provide? Very good. It's a cubic parabola in the ideal shape, but according to IRC beta, actually square parabola is very good. It's a cubic parabola, but for a small deviation angle beta, 2 degree parabola or 3 degree parabola, is almost same beta. Okay, the behavior of 2-degree parabola and 3-degree parabola, the behavior is almost same. So square parabola or cubic parabola will behave same in the case of summit or valley curve. Sorry, in a valley curve, because the angles are slopes are very small here. Okay, so I hope so you know what is the valley curve here, right? What is the equation here? The equation is y is equals to 2n upon 3l square into x cube. This is the equation, and here deviation angle, it means n will be negative. Here n will be negative. Mayank, you will get to know, I think it is on Thursday. Okay, so deviation angle is equals to n will be negative here, right? Now valley curve length is calculated based on which criteria? Anyone can tell me what based on which criteria length of valley curve is calculated? Length of valley curve is calculated based on which criteria? Anyone? Length of valley curve is calculated based on which criteria? Fast, everyone. How do you calculate length? Very good. It's a first one based on the comfort condition. Second one you calculate based on the headlight side distance. Second one you calculated based on the headlight side distance. For based on comfort condition, anyone know formula? The formula is here fixed. Okay, here actually the valley curve is the combination of two transition curve. Okay, the valley curve is the combination of two transition curve. So here the formula is 0.38 under root of n into v cube. Here v is in kmph. And c value is fixed here 0.6 meter per second cube. Okay, in the calculation of valley curve, c value is fixed 0.6 meter per second cube. The formula you can remember directly, 0.38 under root of n v cube. And based on HSD, again you have to consider the two case here when length is greater than HSD, and here second case 2, when L is less than HSD. Okay, I hope so you know the formula here again. The formula is here, length of valley curve is equals to ns square upon 2 into h1 plus s tan alpha. Okay, the formula is here ns square upon 2 into h1 plus s tan alpha. What is h1 here? h1 is here height of headlight. Alpha is our here beam angle. Okay, so according to IRC, h1 is considered as 0.75 meter, alpha is considered as 1 degree. Okay, alpha is considered as 1 degree and this is considered as 0.75 meter. Similarly, if you see here, the formula will be here, LV is equals to, and what is the formula here? What is the formula when L is greater than HSD? The formula is 2S minus 2 into H1 plus S tan alpha divided by N. Okay, so you know the formula again, it will be 0.75 meter height of headlight. Okay, and alpha will be 1 degree beta. So you can put the value here and you will get the answer. S is our HSD, which will be calculated same as I told you already SSD. Okay, which will be calculated same as SSD. Okay, anyone doubt? Anyone doubt? Anyone doubt here? Anyone doubt? This is the completely first chapter beta. One thing I missed. Anyone can tell me what thing I missed? Anyone can tell me what thing I have missed in the first chapter? Anyone? That is very important. One thing I have missed. Anyone? All of you think, 30 seconds you have. Very good, very good, very good. That should be teach before this actually. Okay, anyway, it's okay. One more thing I missed there beta. That is grade compensation. Grade compensation. So what is that grade compensation? Grade compensation is equals to 30 plus R upon R or 70 in percent or 75 by R in percent minimum of that. Okay, so compensated gradient will be equals to shift of curve, Bhagyashree, those things are related to surveying, okay. That will be LS square by 24R, you can write the formula, but I think so you study those things in a surveying. Shift is LS square by 24R, you can remember the formula, but I don't think so the question may come from that, okay. That's the surveying part mostly actually. The compensated gradient will be ruling gradient minus grade compensation. Grade compensation. Okay, but a compensated gradient cannot be less than 4%. It cannot be less than, you cannot compensate beyond the 4% beta. Okay, you cannot be compensate beyond the 4%. So this is very important. Grade compensation is very important. 30 plus R upon R or 75 by R, whatever is minimum. So gradient will be ruling gradient minus grade compensation beta. Okay. This is the case when we do this thing, when on the horizontal curve gradient is there, okay. When on the horizontal curves the gradients are there, then we have to apply the concept of grade compensation, okay. Alright. So this is a completely first chapter. Anyone, any doubt? Anyone, any doubt you can ask me? Anyone, any doubt? Anyone, any doubt? Anyone? Everything clear, beta? So in next 45 minutes we have to complete traffic engineering, okay. If we have to complete whole syllabus, then we have to move little fast, okay. Next chapter we have traffic engineering. I want to cover all the formulas, okay. Next we have traffic engineering. So in traffic engineering basically we have three things. One is traffic characteristics. In that basically we have three things. One is driver characteristics, second one vehicle characteristics, third one we have braking characteristics. Traffic characteristics. This one we have traffic study. Here you will study about the volume study, and here you will study about the volume, speed, delay, O&D, and here you will study about the traffic flow. Okay, and here one more last we have traffic control device. Last one we have traffic control device. Last one we have traffic control device. Okay, so these three, this chapter is divided again into a three different subpart beta. Traffic characteristics, traffic study, and the traffic control device. And here we will study about the signal. Here we will study about the signal, and here we will study about the rotary. Okay, rotary intersections and all. These things we study here, right? Now in a driver characteristics, we have a different characteristics like a physical characteristics, mental characteristics, okay, all these things. So that's not important, but only one thing is, that is the vision. The question have come in 2015 from a vision, okay. The question have come from the vision, but that if you ask me, it's not a transportation question, it's like a aptitude question, okay. It's like a aptitude question. So if I say the vision of any person is 6/9. Anyone can tell me what is the meaning of 6/9 here? If I say any person have a vision 6/9, so anyone can tell me what does it mean? Anyone can tell what does it mean? Actually 6/6 is called as our normal vision beta, okay. If any person have a 6/6, it's called a normal vision. If I say it's a 6/9, so what does it mean? You can check, one question have come based on this concept. What is the meaning of 6/9 vision? Anyone can tell what does it mean by 6/9? The meaning of 6/9 is beta, this thing helps us while we are putting the signals and all on the road beta. Okay, because when the drivers are driving on the road, you cannot say all the drivers have a equal eyesight, right? Everyone have different visions, right? Like I am using the specs of some numbers, I have some vision, you have some vision, right? We also have all the persons have different visions, so definitely we cannot generalize. So this time when you are putting the signals, okay, how much distance the signal should be visible to you, that's why the vision comes into a picture here beta. Okay, you can try today only the question of GATE 2015. What is the meaning of 6 by 9? 6 by 9 meaning is beta, if normal person can see from 9 meter, then this person, which person? Who have a vision 6 by 9, then this person can see the object, from 6 meter beta. Okay, if any person like you have if your vision is 6 by 9, if I am saying, meaning is this, if I can say the vision from 6 meter, I can see the any distance, any object from 6 meter, maybe other, if you are seeing from 9 meter, normal vision is 9 here beta. Okay, 6 by 9 meaning is normal person can say the same object from 9 meter, but other person are seeing it from 6 meter. So this have a poor vision compared to the normal vision beta. Okay, 6 by 9 meaning is it have a poor vision compared to the normal vision. So means normal person can see object from 9 meter, he is seeing from 6 meter. It means he have to come closer to the object to see that. Okay, but if I am seeing one time from here, other time I am coming here, it means I can see from a 6 meter, from here it's like a 9 meter beta. So it have a poor vision beta. You can try the GATE 2015 question. The question have come on the vision, right? Okay. Next is vehicle characteristics. I hope so all of you know the vehicle characteristics. Okay. In India, what is the maximum length is permitted? Or first I write here width of vehicle. Vehicle characteristics. What is the maximum width of vehicle in India? Maximum width of vehicle. All of you tell fast. Maximum width of vehicle. Maximum length of vehicle. Okay. Tell maximum length vehicle, maximum width of vehicle. All of width is 2.44 meter. Length how much? Length how much? Length how much? Length. Maximum length of vehicle how much in India? The length is beta 18 meter. Height of vehicle. Height of vehicle. Anyone can tell what the height of vehicle in India? Height of vehicle in India beta 4.75 meter. Okay. The height of 75 meter is height is required because we have to see the vertical clearance. Okay. Length is required. The length of the vehicle is required because overturning we have to design the horizontal curve. So vehicle must take a turn very smoothly there, and width is required to provide the shoulder, to provide the parking area, to provide the width of the pavement beta. That's why all these three parameters are required during the design of highway. Okay. Last one we have braking characteristics. Last one we have here braking characteristics. Last one we have here braking characteristics beta. Okay, braking characteristics, anyone know? In the braking characteristics, it means we calculate F value. Okay, we calculate F value. So for calculating the F, we conduct a braking test here and we measure three parameters. Okay, three parameters are there. One is initial speed, one is time, second one is length of skid mark. Third one is length of skid mark. Okay, so while we conduct the braking test, three parameters will be calculated: initial speed, time, and length of skid mark. So if you know the any two parameter out of these three, you can calculate the friction value at that pavement beta. Okay, for calculating the friction value, we conduct the braking test. With the help of braking test, these parameters will be noted down. So if out of two parameters you know, you can calculate the f value. Okay, let us say this is u beta, this is t, and this is l. So let us say case 1, if u and l known, I hope so you know the formula, L is equals to u square upon 2gf. With the help of that you can calculate the f value. Case 2, if u and t known, so f is equals to u upon g into t. Okay, case 3, what remains? If what remains? U and what remains? Third case, u and l known, u l knowns, u and t knowns, u l known, u t knowns. What it remains? What it remains? What it remains here? What it remains here? U and l known. Okay, sorry, u square g upon 2l, f square g upon 2l. Right? Yeah, only these things are possible, right? U square upon 2gf, f is equals to u upon gt. Okay, and one more thing here you remember, f is equals to a upon g beta. Okay, sometime they will confuse you. F is equals to a upon g. A is here retardation. A is here retardation. Okay, because it will be braking test, so vehicle speed will be reduced. It will be a upon g. F is equals to a upon g here. Okay, so L is equals to u square upon 2gf, f is equals to u upon gt, and f is equals to a upon g beta. Okay, the question have come based on this formula only in the exam up to now. Okay, L is equals to u square upon 2gf. L is our length of skid mark. Skid mark means when the brake will be applied, the vehicle will be, like you know, the vehicle skid for some length. That is our length of skid mark here. Okay, next topic we have traffic volume beta. Next topic we have traffic volume. Next topic we have traffic volume. What is traffic volume? What is traffic volume? Anyone tell me first? What is traffic volume? What is traffic volume? Anyone tell me first? What is traffic volume? What is traffic volume? Traffic volume means, you know, right here. Traffic volume means number of vehicle crossing a section. Okay, crossing a particular section. This is one number of the vehicle beta. Okay, this is number of vehicle. Okay, in a particular section. How do you measure this? How do you measure this? I hope so all of you know it can be measured with the help of manual method, or it can be help of the mechanical method. So here it can be measured with the help of manual method. If you will measure, it will be so much lengthy process. It will take so much time. Mechanical method if you use, so you cannot differentiate the class of vehicle. So one device is there, I hope so you know. Anyone know which device we use for measuring the traffic volume? Anyone know which device do we use for measuring the traffic volume? Anyone know? Anyone know which device we use for measuring the traffic volume? Anyone? Anyone? No. Here it will pneumatic hose beta. Yeah, man, I am coming to that. Don't worry. I am coming to that. Okay, it's a pneumatic hose. Okay, it will be measured with the help of pneumatic hose. What is pneumatic hose? It's a one tube beta. It's a one tube, in that air will be filled. So when the vehicle will be passed, that tube will be pressed beta. That tube will be pressed. So only one disadvantage of pneumatic hose is it will not count number of vehicle. It will count number of axles. Okay, it will count number of axles. It will not count number of vehicles here. Okay, it will count number of axles, not number of vehicles. Okay, so this is the pneumatic hose. It have come already in ES exam. ES have been already asked which device will be used for measuring the traffic volume. Pneumatic hose. Next one we have representation of traffic volume. Representation of traffic volume. Anyone can tell how do you represent traffic volume? What is the representation of traffic volume? Anyone can tell me first? How do you represent traffic volume? Anyone? I hope so all of you know the terms here. AADT. I hope so you know ADT. Do you know these things beta? A dt A dt. Do you know here A dt A dt? Yes or no? Do you know here A dt or A dt? A dt A dt, you know or not? A dt means annual average daily traffic. This is our average daily traffic. This is our average daily traffic. This is our annual average daily traffic beta. Okay. So now I hope so you know this is daily traffic means it will be based on the annual, it will be based on the week or month. Okay. It will be like it will be total traffic in 365 days divided by 365. So here unit will be vehicle per day. Here it will be total traffic. Here it will be total traffic in week or month divided by, if you are saying week, it will be 7 or 30. Okay, again it will be vehicle annual average. Very good, very good. It will be vehicle per day. Okay, one more we have here, AHT, that is our annual average hourly traffic. That is our annual average hourly traffic beta. That is our annual average hourly traffic. That is what? That is defined as AADT upon 24. This the unit is vehicle per hour. Okay, the unit is here vehicle per hour. Annual average daily traffic divided by 24. Okay, all right beta. Now next we have here expansion factors. The question have come in GATE 2020 from this. The question have come in GATE 2020 from this expansion factor. Right. So I hope so all of you know expansion factor. What is the use of expansion factor? This is used for periodic count. Periodic count means if you know the traffic for a day, how to convert for a month. If you know for a month, how to convert for a year. So these expansion factor will be used. Okay. This will be used for periodic count. Means if you know for a day, how to convert for a month. If you know for a month, how to convert for year. If you know for a week, how to convert for a month. So these factor will be used. I hope so you know. You know the factors beta. You know the expansion factor, yes or no? जल्दी से लिख दो यार कौन कौन से पता है. I have some water. All of you write what is the expansion factor you know. Everyone write. Everyone write. What are the expansion factor you know? What are the expansion factor you know? Anyone know here? Anyone? Any factor? You know? The first factor I hope so you know here. बोलो भाई. Hourly expansion factor. Hourly expansion factor. Next we have anyone hourly. Next we have daily expansion factor. One more we have here. One more we have. Let's write first hourly, then daily. What is hourly? Hourly expansion factor बेटा. Hourly. R से बड़ा क्या हुआ बेटा? एक R मिला के क्या बनता है? If you take a complete hours, what it will be? R to what? R. 1 day 24 hour. So hourly expansion factors are beta total traffic in a day divided by traffic of particular hour. Traffic of particular hour beta. This is our hourly expansion factor. Okay. Now can you tell me what is daily expansion factor? What is daily expansion factor? Anyone can tell me? Anyone can tell me what is daily expansion factor? Here you can see R to day. Now it will be what? Total traffic in a anyone? Total traffic in a anyone tell me fast. Total traffic in a. Why here hourly R to day. Here it's a daily. Daily means it will be total traffic in a week divided by total traffic for a particular day. Traffic for a particular day. Very good, very good. So hourly, it's a daily. Now next I am asking, very good. It's a not month beta Nikhit, it's a week to month, week to day. Bhagya, it's a week to day beta. Okay. R daily day. Okay. Daily day R से बड़ा दिन आ गया, दिन से बड़ा वीक आ गया बेटा, ठीक है. नेक्स्ट वी हैव मंथली एक्सपेंशन फैक्टर. नेक्स्ट वी हैव मंथली एक्सपेंशन फैक्टर. जल्दी से लिखो फॉर्मूला ऑल ऑफ यू. नेक्स्ट वी हैव मंथली एक्सपेंशन फैक्टर, दैट इज डिफाइंड एक्चुअली ADT divided by ADT for particular month. ADT for particular month or ADT for a particular month beta. Okay, ADT for particular month. ADT upon ADT beta. The question have come already in GATE 2022. You can try. Okay, question have already come in GATE 2020. Sorry, not 22. It have already come in GATE 2020. From this also the question have come from this. So just remember these factors. It will be important beta. Okay. One more thing is there. Note I am writing 30th hourly traffic volume. I hope so all of you know. In India, this is our design traffic volume. This is our design traffic volume. This is our design traffic volume. What is the meaning of 30th hourly traffic volume beta? What is the meaning of 30th hourly traffic volume? It is the hourly volume which will be exceeded how many times? It is the hourly volume. It is the hourly volume. It is the hourly volume which can be exceed how many times? The GATE have asked this question already. Which can exceed how many times? Which can exceed 29 times in a year beta. In a year. Okay. So this is the volume which can be exceed only 29 times in a year. Okay. Actually for in India, the design volume age, the design hourly volume age considered as 8 to 10% of ADT beta. This question may come in the exam. This is 8 to 10% of ADT. Design hourly volume is 8 to 10% of ADT. This may come in the exam. Okay, this data is important. It can come in the exam. 8 to 10% of ADT beta. Okay. Chalo. So this is the all about the traffic volume. This is all about the traffic volume. One thing is there. One more thing is here. I hope so all of you know. Anyone can tell me? One factor I am missing. One more factor I have to write here. Anyone can tell me? Anyone can tell me? Which factor I am missing here? Anyone can tell? Which factor I am missing here? अब guess करो भाई. पहला अल्फाबेट P लिख रहा हूं मैं. Anyone? Which factor I am missing? Peak R factor. Peak R factor. Okay. One more. I hope so you know that it. No, Bhagyasri. It's a peak R factor. I hope so you studied about the PHF, right? The question have come already in the last year only. The PHF. PHF 5 or PHF 15. Okay. So what is that? PHF 5 or PHF 15? The PHF 5 is total hourly volume. Total hourly volume. It is always same. Means in the numerator, it's always total traffic volume, total hourly volume beta. For both. Divided by 60 by, it's a 5, 60 by 5. It's a 15, 16 by 15. Multiply by V5, multiply by V15. What is V5? What is V15 here? V5 is maximum traffic volume. Maximum traffic volume in 5 minutes. Here it's a maximum here it's V15, maximum traffic volume in 15 minutes beta. You know or not this thing? P car factor, everyone know P car factor beta. P car factor, everyone know. The question have come recently, last year only. Okay, the question have come recently from this, right? The question have come recently from this. Total hourly volume 60 by 5 into V5. Maximum traffic volume in 5 minutes, maximum traffic volume in 15 minutes. Now, what is the maximum value possible of this? The value of peak hour factor is lie in between, I am writing general formula, 1 upon 60 by time. Time means whatever time is given to you. It can be PHF 5. So, if I say here for PHF 5, the range of this will be 1 upon 60 by 5 less than equals to PHF less than equals to 1. So, you can say here it will be how much? It will be 1 by 12 to 1. It can be 1 by 12 to 1. Similarly, if I say here for PHF 15, what you will say? 1 upon 60 by 15 less than equals to PHF 15 less than equals to 1. So, it will be how much? It will be 1 by 4 PHF less than equals to 1. I hope so all of you know this thing, right? I hope so all of you know this thing, right? Next we have traffic speed. जहां हो वहां रोक लेना बेटा, जहां डाउट हो वहीं रोक देना, वहीं रुक जाऊंगा, ठीक है? नहीं तो भागता रहूंगा. जहां डाउट हो वहां रोक दो, कोई दिक्कत नहीं है, ठीक है? कोर्स बहुत सारा है, तुम्हें पता है, अभी कोर्स बहुत सारा रह गया है, ठीक है? सिलेबस सब खत्म करेंगे आज ही, सारे फॉर्मूले रिवाइज करने, सारे. I will not leave any single formula. We have to cover it all the formulas, right? Next we have speed study beta. Next we have speed study. I hope so all of you know here two speeds are important. One is time mean speed. One is time mean speed. Second one is space mean speed. Time mean speed. And next one we have space mean speed. जल्दी से formula लिख दो फटाफट. Time mean speed, space mean speed. Everyone write the formula fast. Time mean speed is what? This is the arithmetic mean of the speed. This is the harmonic mean of the speed, right? This is arithmetic mean. This is our harmonic mean of the speed. So sigma vi upon n upon 1 upon sigma. I am writing here. It's arithmetic mean. This is our harmonic mean. So you know what? Arithmetic mean is always greater than harmonic mean. So I can say here time mean speed will be always greater than space mean speed बेटा. कर रहे हैं बेटा, कर रहे हैं. मैं तो पक्के कर रहा हूं अपने, तुम्हें अपने करने हैं, ठीक है? यहाँ पे Vt will be always greater than Vs बेटा, ठीक है? Sigma Vi upon n upon 1 upon sigma Vi. So time mean speed, the question have come recently. The question have come recently from this. Time mean speed, space mean speed. Okay. Okay, beta. Other than that, we have two more speed. I hope so you know. Anyone know? Other two speed. I hope so you know also. Running speed and journey speed. And journey speed. Running speed is what beta? Total distance divided by running time. Running time means you will not take the delay. Means अगर जाम लगा हुआ है तो वो टाइम काउंट नहीं होगा. जो रनिंग टाइम है जिसमें तुम दौड़ा रहे हो वही टाइम काउंट होगा खाली. जर्नी स्पीड मीन्स टोटल डिस्टेंस divided by total distance means journey time. Means total time will be counted in a journey speed, but in running speed only the running time will be counted. Okay. Anyone doubt you can ask me beta. Anyone doubt you can ask me. Anyone doubt you can ask me. And how do you measure this beta? How do you measure? No, I will come beta. Nikhil, I will come to that. I will come to that. How do you measure the speed beta? Speed study. How do you measure the speed? How do you measure the speed? How do you measure the speed? Anyone? For speed measurement, which device we use? I hope so all of you know. That is mirror box method. That is mirror box method, also known as or anoscope, right? Or anoscope. I hope so you know. Not unit I am asking beta. means how you will measure, which device you will use. That's a mirror box or it will be a anoscope. I hope so all of you know, right? I hope so all of you know mirror is box method or anoscope method, right? Now come to the representation of speed. Representation of speed. Now here I hope so you know what? You know here 98th percentile speed. You know here, जल्दी से लिख दो क्या गया फटाफट, जल्दी लिख दो क्या गया बेटा. 98th percentile speed, 85th percentile speed और 15th percentile speed और बेटा 50th percentile speed. Yes or no? Okay, what is 98th percentile speed? What is 98th percentile speed beta? What is 98th percentile speed? What is 98th percentile speed? Everyone tell me fast. Everyone, very good. Design speed. For this speed, the highway will be designed beta. This is my geometric design speed. This is my geometric design speed. This is what? 85th percentile speed. 85th percentile speed is what beta? This is our upper safe limit. This is our upper safe limit. This is for regulation of traffic. Okay. 50th is our lower speed limit. That is for avoiding the congestion of the highway. Okay. If the vehicles are moving less than 15th percentile speed, the jam will be there on the road. If the vehicles are moving 85th percentile speed, तो भगवान भरोसे हो भाई, मर भी सकते हो. ठीक है, डिजाइन तो कर दिया 98 के लिए, बट आईआरसी ने बोला भाई जोड़ाना, तुम्हें जो व्हीकल को चलाना है वो 85th पे ही चलाना है, इससे ऊपर चलाओगे तो भगवान भरोसे हो, मर भी सकते हो तुम, कोई दिक्कत नहीं है हमें. ठीक है, तो हमें कहा व्हीकल चलानी होती है हमेशा 85 से 15 के बीच में. तो डिजाइन तो किया है 98 के लिए, क्योंकि तुम और मैं, हमने सबने स्पीड लिमिट से ऊपर व्हीकल चलाई है, तो एक्सीडेंट तो नहीं हुआ हमारा, राइट. तो डिजाइन तो 98 के लिए थी, बट हमें जो व्हीकल चलानी है हमेशा 85 और 15 के बीच में चलानी है बेटा. एंड लास्ट 15 परसेंटाइल स्पीड, दैट इज कॉल्ड एज अवर मीडियन स्पीड. That is called as our median speed. Anyone doubt you can ask me. Anyone doubt you can ask me. So this is our completely speed study beta or spot speed study. Anyone? 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 Next we have speed delay study. Next we have speed delay study. Okay, so anyone can tell me how do we measure? How do we do delay study? Which method we use? Anyone tell me how do we measure? Which method you use here for delay study? For measurement, which method do you use here beta? Which method you use here for measurement? First यार, एक इम्पोर्टेंट मेथड जो बहुत इंपॉर्टेंट है, फटाफट बताओ क्या नाम है उस मेथड का, फटाफट. एवरीवन, which method is there for delay study? Which method is there for delay study beta? The method is what? Method is here beta, the floating car method, the floating car method or moving car method. Floating car method or moving car method. Other than that we have a license plate method, कोई यूज नहीं करता. लाइसेंस प्लेट मेथड भी है और इंटरव्यू मेथड भी है, ठीक है बेटा. बट मैथमेटिकली ओनली दिस इज देयर, मैथमेटिकली ओनली दिस इज देयर, फ्लोटिंग कार मेथड और मूविंग कार मेथड. आई होप सो ऑल ऑफ यू नो अबाउट दिस मेथड ऑल्सो. जल्दी से लिख दो फॉर्मूले क्या है बेटा. फ्लोटिंग कार मेथड और मूविंग कार मेथड. हाँ, क्यों करते हैं डिले स्टडी बेटा? हमें पता करना होता है अगर कहीं पे जाम लग रहा है तो जाम लगने का रीजन क्या है बेटा. दैट्स व्हाई वी डू द डिले स्टडी बेटा. ओके, फॉर नोइंग द कंजेशन, व्हाट द, for knowing the congestion we do the, for detecting the spot of the congestion. Delay study is removed? No. Okay, the formula is here, floating car, moving car. Just okay, just take a minute, write the formula here. Okay, the formula is here. In this we have a two formula. What is that? Q is equals to Na plus Ny upon Ta plus Tw. Second one we have here T bar is equals to TW minus NY upon Q. Okay, T bar is equals to TW minus NY upon Q. Okay. I have seen. Okay, TO is equals to NA plus NY upon TA plus TW. T bar is equals to TW minus NY upon Q. So this formula you can remember. Okay, so this is our delay study. Next we have O and D study. Anyone know what is O and D study? Anyone know what is O and D study? Anyone know what is O and D study? हाँ मयंक नहीं आएगा यार. Yeah, I missed that thing in my mind. O and D study. What is O and D study? O and D study. This is our origin and destination study. Beta. Okay. Only thing is here how to represent the data of O and D study. Okay. The data will be represented with the help of desired lines, beta. The data of O and D study is represented with the help of desired line. Anyone can tell me? 1 second. Sorry. Yeah. The desired lines is the representation of O and D study. So here what is the important concept? Thickness of desired line is proportional to, anyone know? The thickness of desired line is proportional to what? The thickness of desired line. This is the IAS question already. IAS exam have been asked. Thickness of desired line is directly proportional to number of trips in both direction. Okay, number of trips in both direction. This is my O and D study, beta. Okay, only this thing you have to remember. How do you represent? By with the help of desired lines. Okay, with the help of desired lines we represent this. Okay. चलो अब आ जाओ मोस्ट इंपोर्टेंट पार्ट ऑफ द ट्रैफिक इंजीनियरिंग, दैट इज ट्रैफिक फ्लो कैरेक्टरिस्टिक्स. आई होप ऑल ऑफ यू नो traffic flow characteristics. What are the traffic flow characteristics? Basically we have two types of characteristics here. One is macroscopic, other one is microscopic. Anyone tell me what are the macroscopic characteristics? Anyone can tell me what are the macroscopic characteristics, beta? What are the macroscopic characteristics of the traffic? Anyone? First one is here traffic flow. Second one is here traffic density. Third one is here traffic speed. This is our Q, this is our K, this is our V. So what is the relationship between Q, K and V? Anyone tell me? What is the relationship between Q, K and V? Anyone tell me first? Q, K and V first. What is the relationship between them? The relationship is Q is equals to K into V, beta. Q is our traffic flow, which will be generally in a vehicle per hour. Okay, K is our density, it will be vehicle per kilometer. Speed will be kilometer per hour, beta. Okay, so Q is equals to K into V. अब एक बात दिमाग लगा लो, अब तुम्हें बहुत सारे मॉडल पढ़े होंगे तुमने, ग्रीन सील्ड मॉडल, ग्रीनबर्ग मॉडल. एक चीज है बेटा, this relationship is always valid. Mayank, you was asking me curve na beta. The curve fundamental start from here and end here only. Q is equals to KV is applicable always. This relationship is universal relationship. Doesn't matter which model you are using, green sealed, green wood, underwood, whatever you are using, Q is equals to KV will be applicable all the times, beta. Okay. What are the microscopic characteristics? I hope so you know. Here it is space headway. Here it is space headway, and here we have time headway. Here we have space headway, and here we have time headway. Yes or no? Space headway and time headway. So with the help of what is space headway? It is the space gap maintained between the two successive vehicles. So with the help of space headway, we define density K is equals to 1000 upon S, where S is in meter and the unit will be here vehicle per kilometer. S is here space headway. S is here space headway. S is here space headway beta. Time headway is what? With the help of time headway, we define the C or Q. You can say Q is equals to 36 by HT. HT is in second, and here you will get in vehicle per hour. Okay, so here you can say HT is equals to time headway. HT is equals to time headway. सब याद है ना बेटा? सब याद है ना? सब याद है 1000 upon S 136 by HT सब याद है? ट्रैफिक फ्लो निकाल रहे हैं विद द हेल्प ऑफ टाइम हेडवे, डेंसिटी निकाल रहे हैं विद द हेल्प ऑफ स्पेस हेडवे बेटा. ओके ओके, क्लियर? एवरीथिंग क्लियर? एवरीथिंग क्लियर? एवरीथिंग क्लियर? नेक्स्ट आ जाओ ट्रैफिक कैपेसिटी पे. नेक्स्ट आ जाओ ट्रैफिक कैपेसिटी पे. So basically we have a three types, but possible capacity have a no numerical. So first we have ideal capacity or basic capacity or theoretical capacity One more we have, that is design capacity or practical capacity. Design capacity or practical capacity. Okay, तो फॉर्मूला इसका पता ही होगा. C इज इक्वल्स टू 1000 V अपॉन S, वेयर S इज इक्वल्स टू 1000 V अपॉन S इज इक्वल्स टू SSD प्लस L बेटा in meter, and here answer will be here vehicle per hour. Okay, capacity will be vehicle per hour 1000 V upon S. हाँ बता रहा हूँ, रुक जाओ. 1000 V upon S, and in ideal capacity what change happen beta? In ideal capacity only one thing is there. What IRC said to you beta, in SSD IRC is saying the braking distance is 0 and the time have been not 2.5 second, time is only 0.7 second. So here the formula is 1000 V upon S, but S is equals to here 0.7 V plus L beta. Okay, it's a 0.7 V plus L. Braking distance will be considered as 0. Okay, braking distance will be considered as 0 and the time will be 0.7 second here. So this is our design capacity, this is our practical capacity beta. Okay, so traffic capacity, if question is not mentioning any capacity, always calculate here design or capacity. Okay, what is L here? L is our wheelbase or length of the vehicle again. Okay, any doubt? Any doubt up to now? Any doubt up to now? This is our traffic capacity beta. Next we have traffic flow models. I hope so you know. First one is we have green shield model. First one you know, I hope so, green shield model. First one, I hope so all of you know green shield model. What is that green shield model? What is green shield model? You know the relationship between K and V is linear. The relationship between K and V is linear beta. Okay, so if you write the equation, and here the density is Kj, here the speed is Vf. So if you write the equation here, V is equals to Vf 1 minus K upon Kj. Now Mayank, I am coming to your point what you are saying beta. सर जो कन्वर्जन है वो आते कहां से हैं, कैसे करते हैं बेटा? ये पता है ये इक्वेशन कहां से आती है मयंक? डू यू नो दिस हाउ दिस इक्वेशन इज कमिंग? V is equals to Vf 1 minus K upon Kj. ये पता है कहां से आती है? ये पता है बेटा कहां से आती है इक्वेशन? ये इक्वेशन कहां से आई है? एवरीवन नो हाउ दिस इक्वेशन इज कमिंग? V is equals to Vf 1 minus K upon Kj. You know how this equation is coming? Yes or no? Yes or no? You know this equation how it's coming? Yes or no? You know or not? If you know this equation, you can make the any curve beta. If you know the basic concept how this equation is coming, you can make any curve. नहीं पता? बेटा ये क्या है, स्ट्रेट लाइन है, ये क्या स्ट्रेट लाइन है, यस और नो, स्ट्रेट लाइन है। स्ट्रेट लाइन की इक्वेशन क्या होती है, y इज इक्वल टू mx प्लस सी। स्ट्रेट लाइन की इक्वेशन क्या होती है, y इज इक्वल टू mx प्लस सी। y पे क्या है अपना, y पे क्या है अपना, y एक्सिस पे क्या है अपना, y एक्सिस पे क्या है अपना v, x एक्सिस पे अपना क्या है k प्लस सी। कितने अननोन है यहाँ पे बेटा, वी हैव अ टू अननोन m एंड c. इट मींस टू अननोन्स आर देयर, आई नीड टू बाउंड्री कंडीशन. Two unknowns are there, I need two boundary conditions. So can I say here at k is equals to kj, v is equals to 0. Can I say also at v is equals to vf, k is equals to 0? Yes or no, Mayank? Can I say this thing or not? At k is equals to kj, v is 0. At v is equals to vf, k is 0. Yes or no? Okay. So now put these two conditions here. You will get this equation, बेटा. Same काम करना है वहीं पे, सेम काम करना है वहां पे क्या करोगे, जो दिया हुआ है ना उसकी इक्वेशन लिख लो पहले बेटा, और उसके बाद क्या करो, तुम्हें पता है रिलेशनशिप Q इज इक्वल टू K इंटू वी, पुट कर दो उसको यहां पे, अपने आप समझ में आ जाएगा उनका रिलेशन कैसे है आपस में बेटा, उनका रिलेशन कैसे आपस में समझ में आ जाएगा। तो कर्व ड्रॉ कर देना यार। अगर क्वेश्चन की बात करें जो 2020 में आया है, वो इट लुक्स लाइक अ पैराबोला, इट्स अ हाइपरबोला टेकिन, ओके, इट लुकिंग लाइक अ parabola. They have not mentioned because it's a parabola or hyperbola, but it's a hyperbola. The question came in 2020, right? Okay. So basic funda is how to write the equation of line first and put here in Q equals to KV. You will automatically understand how the parameters are varying with each other, right? So now this is the equation. I hope so you know here for Q is equals to Q max. For Q is equals to Q max, I hope so you know K will be equals to Kj by 2 and V will be equals to Vf by 2. K is equals to Kj by 2, V is equals to Vf by 2, right? So now you know here Q will be equals to, Q max will be equals to Kj into Vf by 4. I hope so everyone know. I hope so you all know everyone, Kj into Vf by 4 and Kj will be equals to here beta, Kj will be equals to 1000 upon Kj will be equals to what? जैम लग गया है, स्पीड जीरो हो गई है, एसएसटी जीरो हो जाएगा, 1000 अपॉन एल इन मीटर व्हीकल पर किलोमीटर. Kj means what? Kj is our jam density. Kj is our jam density and Vf is our free flow speed beta. Vf is our free flow speed. Okay, so 1000 upon L in meter, it will be our Kj value. Anyone doubt? This is our green shield model. I hope so you know how to draw the curve in between that. तो मैं बेटा अगर वो कर्व यहां पे अगर कर्व सीख लिया ना तो वो कर्व भी ड्रॉ हो जाएंगे. Here K is there, here V is there. You know here it's a straight line. Here I am saying it's a V. Here it's a Q. Here I am saying it's a K and here I am saying Q. So you know Q is equals to, sorry. Bhagyasiri, if you see the answers of those questions, they have given marks to all for those questions. Okay, the questions were not properly framed, and if you ask those questions are in a master's level question. Okay, the completely out of picture. The concept is not at all relevant to these things. So if you see the answer key of those questions was marks to all question beta. The marks was given to all students for those two questions. Two questions came in 2020. Okay, so for those two questions, the marks is given to all students. You can check. Okay, so if you see here, the curve will be here parabolic like that, and here it will be parabolic like that. Now the question may come in your mind, how parabolic? I am saying Q is equals to KV beta. Q is equals to K into V is how much? V is Vf into 1 minus K upon Kj. So you can see here, it will be K square. So Q is K square proportional is there. It means curve will be parabola. Okay. So here it will be at Kj by 2 and Vf by 2, Q will be maximum. Here it will be Kj by 2 and here it will be Vf by 2 beta. Okay. So if you know these three curves, now how it's coming, all curves you can draw which came in the exam beta. Okay. If you know these three curves, how it's coming, the basic is same for all the curve here. Okay, the basic is same for all the curve. Anyone doubt? Anyone doubt? Anyone doubt beta? Anyone doubt anything? Anything, anyone? Anything, anyone? Next, I hope so you know the probability questions, right? I hope so you know the probability question, right? Probability questions are coming. So what is that? Vehicle arrival distribution. What is that? Vehicle arrival distribution. The vehicle arrival distribution beta. Okay, the vehicle arrival distribution. I hope so here you know two distributions are there. One is exponential, one is Poisson, which you already studied in the mathematics also, right? So here if you draw the curve for the exponential distribution, the curve comes like that. Okay, on x-axis we consider that time. Okay, on x-axis we consider the time, and on y-axis we have vehicle arrival. Okay, vehicle arrival. Vehicle arrival rate is generally lambda. We denote our vehicle arrival rate, right? So here, if any time t is there, the area of a probability, okay, probability of this t, time is this beta, time is greater than this, okay, probability is time is greater than this, okay. So the here time is greater than, let us say t, here it's a time is t is greater than some value x, okay, here it's a time is t, okay, 1 second. If ht is greater than t, time had to be greater than t, the probability will be e to the power minus lambda into t. If p is less than t, the probability will be 1 minus e to the power minus lambda t. And if it's a tooth, if question is asking to you probability between two time headway x and y. Okay, the question is asking to you probability between two time headway x and y. So how you will write? It will be probability in between time headway in between x and y, it will be e to the power minus lambda x minus e to the power minus lambda y. E to the power minus lambda x, e to the power minus lambda y. Okay, this is our exponential. And for Poisson, you know, if p n number of vehicles are passing in a time t, it will be e to the power minus lambda t to the power n upon n factorial. Okay, so this is the Poisson distribution. I hope so all of you know. I hope so all of you know here, right? So this question may come, the questions are very important from this, but it's a directly formula based. Why I am going little fast here? Because mathematics you already studied these things, right? Poisson distribution and exponential distribution already you have studied. So these are the direct formula which you can write directly beta. Okay, next one we have, I hope so you know, delay study. How many have studied this thing? Okay, delay study beta. How many of you know in detail about the delay study? Or delay analysis? How many of you know about delay analysis? Have you studied beta? The question have come various time from the delay analysis. If you see the recent question papers, the delay analysis questions have come already. The question have asked you calculate the average delay. Okay, the question have asked you average delay various time. All of you know average delay, how to do. So here mostly one curve will be given to you in the question beta. Here it will be time, and here it will be cumulative vehicle arrival. Cumulative vehicle arrival. We assume that the vehicle is arriving with a uniform rate. So here you will see we assume that the vehicle arrival rate is straight line beta. This is our vehicle arrival. Okay, and here we have red time, and here we have green time, and this is our cycle length, let us say. Okay, this is our cycle length, let us say beta. Okay, so now here the cost, and if I draw one more line here, this will be our departure line. This will be our departure line. Now what does it mean beta? when the red time is there, the vehicles are stopping, the vehicles are stopping, the vehicles are stopping. When the green time starts, the vehicle is moving, vehicle is moving, vehicle is moving. But I cut the two lines here. It means that when the red time is, when the green time is over, all the vehicles have been passed, beta. When the green time is over, all the vehicles have been passed. Now the question comes how to find the average delay. So average delay will be found as area of this triangle divided by, I am saying, let us say here the vehicle number is n beta, divided by cumulative number of vehicle beta. Okay, so average delay per vehicle. Why per vehicle? Per vehicle means you have to divide the total cumulative number of vehicle. Average delay per vehicle is equals to area of shaded region divided by n beta. N is number of cumulative vehicle here beta. Okay, now maybe you know the direct formula also. So average delay per vehicle is also calculated with the help of some formula. Okay, maybe you know the formula. The formula is C by 2 1 minus what is that? C by 2 1 minus, anyone know? GI by C 1 minus GI by C. Actually I brought this topic little before. GI by C whole square divided by 1 minus lambda upon mu. C here cycle length. C is here cycle length. I will discuss these things in detail, but actually that it was related to the vehicle arrival, so I took here. GI is here effective green time. Lambda is here vehicle arrival rate, and mu is here vehicle. Maybe you studied V by S. Okay, anything you have studied, vehicle departure. So you can, with this formula also you can calculate average delay per vehicle. Okay, with this also you can calculate average delay per vehicle beta. This is very important for the exam point of view. This is very important topic for the from the exam point of view. Average delay. Okay. Next is actually signal design. Next, I hope so. This is our signal design. Okay, I hope so you know. So our, what is cycle length? Anyone know? What is cycle length? Cycle length is, anyone know what is cycle length beta? Cycle length we denote with C generally. It is equals to green time plus amber time plus red time. Green time plus amber time plus red time. Okay. Now if I ask you here effective green time, what is effective green time? Effective green time you denote with GI is equals to G plus A, green plus amber time minus delay. Beta. Delay means it can be startup delay, it can be the all red time beta. Okay, so G plus A minus the delay time, that will be given to in the exam. So this is our effective green time. This is a general formula beta. G plus A minus delay. Okay, it can be the startup lost time, it can be the clearance lost time. Okay, it can be the TSL, or it can be our TCL, startup lost time or clearance lost time. Okay, so this is our G plus A minus delay time. Now here which method is important? I hope so all of you know. Which method is important for a signal design in the exam? I hope so all of you know. Which method? Beta? Which method is here? One more thing I am writing here, maybe it can be asked you, maybe you know or not directly. Capacity of a lane beta. Capacity of any lane, if these things are there, so is equals to C is equals to 36 by H into GI upon C. I should write C naught here, C naught. Okay, H is here, time headway, H is here, time headway, GI is effective green time, okay, effective green time, and C naught is our cycle length beta. Okay, so if GI and C naught is given to you, then you can calculate capacity of any lane in this way also, and GI by C naught is also known as effective green ratio. Okay, this is also known as effective green ratio. Okay, one more thing here, time required to cross n number of vehicle. How much time is required to cross the n number of vehicle of any signal? That time is given as, anyone can tell how much time is required? N into H plus TSL beta. N is here, number of vehicle, H is here, time headway, H is here, time headway. Again, these formula you have to remember. Okay, maybe I am sure most of you don't know these formula, right? But it can come in the exam. It can come in the exam. Time required to cross n number of vehicle of any signal. This is, and TSL is startup lost time. TSL is our startup lost time. Okay, this is our time required to cross the any signal. Alright, so now I am moving to the most favorite or most important topic, that is our Webster method. What is the basic principle of Webster method? The basic principle of this is average delay should be minimized. Average delay should be minimized. That is the basic principle. Now what is the formula here? 1.L plus 5 upon 1 minus y. Okay, what is L here? L is here total lost time. How do you calculate L? Value here, beta? How do you calculate L value here? N into TSL plus all red time. Okay, which maybe you know directly, it will be 2n plus r. Okay, because TSL will be given to you. TSL is considered as 2 seconds, and n into all red, it will become r. So L is equals to 2n plus r. What is n here? Beta? What is n here? Anyone tell me? What is n here? N. What is n here? Fast. What is n here? Anyone? N is how much, beta? N is here number of phases. Okay, N is here number of phases, right? So n plus r, and y is here ratio of normal flow to the saturation flow. Beta. Okay, that will be y1 plus y2 plus yn, depend upon the number of phases, and based on that we calculate effective green time. G1 is equals to y1 upon y into C naught minus L. G2 is equals to y2y by into C naught minus L. Okay, so effective green time will be calculated in the Webster method by this way. I hope so all of you know. I hope so all of you know. Beta. Yes or no? I hope so all of you know, right? Next we have here, beta, rotary design. Capacity of rotary formula, I hope so you know. Rotary design, only the one time the question have come from the rotary design. Anyone can tell me what the rotary design formula? Anyone? I hope so all of you know. The capacity of rotary, practical capacity or design capacity of a rotary is given by C is equals to 280 into W 1 plus E by W into 1 minus P upon 3 divided by 1 plus W by L. I hope so all of you know, right? What is W here? What is E here? What is P here? What is L here? Okay, and this will be our PCU. This will be our passenger car unit per hour. Okay, PCU per hour. So what is E here, beta? E is our average width, E1 plus E2 by 2, entry width or exit width by 2. W is here E plus 3.5 meter. If it's not given, this is called as our width of rotary. This is our width of rotary. Okay, this is average of entry and exit width. This is our average of entry and exit width. What is P here? P is our weaving ratio or proportional ratio. Okay, P is our proportional ratio or weaving ratio, beta. Okay, it's defined as weaving traffic divided by total traffic. And what is L here? What is L here, beta? Anyone can tell what is L here? What is L here? L is our weaving length. L is here our weaving length. Okay, so this is the so many data is there in the rotary. Okay, I am not thinking that is important. Okay, so many data is there. Okay, L should not be more than 4W, beta. Okay, L here should not be more than 4W. What you are writing, Bhagyasri? Okay, L is not 4W. L should not be less than 4W. Okay. So this is the complete all about the traffic engineering, beta. Okay, this is completely about the traffic engineering. Okay, did I miss anything? Did I miss anything? Did I miss anything here? Did I miss anything here, beta? Chalo. Next alo. Next is our highway materials. Next is our highway materials. जल्दी से कर देंगे बेटा इस हाईवे मटेरियल को ना. Highway materials. So I hope so you know what are the materials we have. What are the materials we have? One is soil subgrade. Soil subgrade. Second one is here aggregates. Second one is aggregates. Third one we have bitumen. Third one we have bitumen. So what are the tests we perform on subgrade? Anyone tell me first? What are the tests do we perform on subgrade? Anyone tell me first? Plate load test. And you know I think here CBR method. On aggregate. First all of you write the test name on aggregates. What are the tests you know about the aggregates? All of you write the names. What are the tests you know about the aggregates? All of you write the name. Plate load test is for soil. CBR test is also for soil. Do it fast. Very good, very good. I hope so you know here we perform crushing test or anyone else. Next crushing test. Next impact test. Next abrasion test. Next shape test. Yes or no? Anything else? Crushing test, impact test, abrasion test, shape test. Anything else? Anything else, beta? Anything else? Soundness test. Yes or no? Also we perform stripping value test or adhesion test. Stripping or bitumen adhesion test. Yes or no? So let's talk here only first. Crushing test why do we perform crushing test beta? Crushing test, why do we perform crushing test? Resistance against gradual load. Resistance against gradual load. Okay, let me write bitumen later here. So resistance against gradual load, or you can say compressive strength. Okay, or you may say compressive strength. Impact test we perform for impact loading, or you can say here impact load, or you can say here toughness. You can say here toughness. Next, abrasion test we perform for hardness, or you can say for wear and tear of aggregate. Sorry. Wear and tear of aggregate. Shape test. In shape test, we have a 3 types of test. I hope so all of you know. What are the 3 types of shape test you know? What are the shape test you know? Tell me fast. What are the shape test you know? One is flakiness. Second one is elongation. Third one is flakiness, elongation, and one more is there beta, angularity number. One more is there, that is angularity number, right? So I hope so you know in a flakiness one thing is important, the least dimension must be less than 0.6 times of mean dimension, and here it will be greater dimension must be greater than 1.8 times of mean dimension. I hope so you know these data. Okay, and angularity number varies from 0 to 11. Angularity number varies from 0 to 11. Okay, and soundness test is performed for resistance against weathering action. Resistance against weathering action. Resistance against weathering action. Okay, and why do we perform adhesion test? Why do we perform adhesion test beta? For seeing the binding. Okay, this is for binding between the aggregate and bitumen. Okay, so this test is performed for binding between the aggregate and bitumen. Now come to the plate load test. Now come to the plate load test here beta. Plate load test. Plate load test, I hope so you know what is the size of plate. Size of plate is how much? Size of plate is how much here? Size of plate is how much in a plate load test, everyone? What is the size of plate in a plate load test? What is the size of plate in a plate load test? Everyone tell me fast. What is the size of plate in a plate load test? It is 75 centimeter, and we use here rigid plate, and here we use rigid plate beta. Okay, and deflection, or sorry, load measured. Can you tell me the load measured corresponding to how much deflection? The load measured corresponding to how much deflection? The load measured corresponding to how much deflection here? 0.125 centimeter. Okay, and this is used for measuring this test we use for modulus of subgrade. The modulus of subgrade, which is denoted as K is equals to P upon delta. So unit is generally kg per centimeter cube. K is equals to P upon delta. Delta is 0.125 centimeter beta. Okay, so this is used for measuring the modulus of subgrade. Okay, all right. Anyone doubt? I hope so you know here delta formula, you know 1.18 into PA upon ES. Okay, so here you can see 1.18 ES, and A is P to P will be cancelled. So you can say here by using this Ka is equals to constant. Okay, so relationship between K and A is Ka is equals to constant. So you can say K1A1 is equals to K2A2. It means you can see the relationship between K and A. Okay, Ka is equals to constant. Modulus of subgrade multiplication with the radius of the plate. Okay, That is the multiplication is constant here beta. Okay. Next one we have CBR method. Next one we have CBR method. Next one we have CBR method. This is used for measuring the relative strength. This is used for measuring the relative strength. Okay. And what is it? How it's defined? CBR in the percentage defined as load carried by the specimen divided by standard load multiplied by 100. So here the penetration is 2.5 mm. I hope so you know. And here it's a 5 mm. And the load corresponding standard loads are, anyone know? What is the standard load corresponding 2.5 mm? What is the standard load beta? Here the value standard load is 1370 kg. Here it is 2055 kg. Okay. Now maybe in the exam they will not give you load, they will give you the pressure. Okay. So you can write here 70 kg per centimeter square. Okay, and 105 kg per centimeter square. How it's coming? The load divided by the area of that piston beta. Okay, area of piston if you will divide, you will get 70 and 105 here beta. Okay, so how you do? You always calculate the CBR for both, but whatever maximum is there, that you will consider as an answer, right? Whatever maximum is there, you will consider for 2.5 mm, you will calculate for 5 mm. So whatever maximum is there, that will be answer. But mostly it comes maximum for 2.5 mm, but it's coming for 5 mm. Let us suppose, then what will happen? We will perform the test again, and after that also if you found it's more for 5 mm only, then it will be considered as an answer. But it comes maximum for 2.5 mm more times. Okay. So this is our CBR method. CBR method means California bearing ratio. The question have come beta. It is used for measuring the relative strength of a soil. Okay. It is used for the measuring the relative strength of the soil. Okay. Now next come to the test on bitumen. Next come to the test on bitumen. Test on bitumen. Tell me fast what are the tests? Tell me fast what are the tests for bitumen? Tell me fast what are the tests for bitumen beta? Fast. What are the tests for bitumen? What are the tests for bitumen? All of you write fast. What are the tests for bitumen? I hope so you know. Penetration test. Penetration test. Viscosity test. Also ductility test. Also anyone? Softening point test. Also I hope so you know flash and fire point test. Flash and fire point test. Okay. Anything else? Anything else? Anything else? Penetration test, viscosity test, ductility test, softening point test, flash and fire point test. Anything else? So many tests are there, right? So many tests are there. So many tests is there, beta. Anyone can tell? Other than that, one more test is there if you see here. Anyone know? What are the tests here? One more is there, spot test beta. Spot test. It is used for checking the bitumen is cracked or not. Solubility test is also there. Okay. Let's write this. Those are the things which have been asked in exam or important also. So in a penetration test, what is the use of penetration test? Why do we conduct penetration test on a bitumen? For checking the bitumen is hard or soft. Okay. For checking the bitumen is hard or soft. So here in the penetrometer, here we use the penetrometer. Here we use penetrometer, and the deflection in this reading will be measured as 1/10 of mm beta. 1 by 10th of mm. Means if the reading is 80, so penetration will be 80 by 10, 8 mm beta. If reading is 100, it will be 100 by 10, the penetration will be 10 mm. So it will be 1 by 10 mm, and test is conducted on 25 degrees centigrade. Okay, the test is conducted for the 25 degrees centigrade. Second, we have viscosity test. It is used for resistance of flow. It is used for resistance of flow. Second, we have ductility test. It is used for adhesiveness or elasticity of bitumen and elasticity of bitumen. Second, we have softening point test. Here, this is also known as ring and ball test. I hope so you know. And in this, what you measure beta? Here you measure the temperature, and the value of temperature is 35 to 70 degrees centigrade, right? And what is the meaning of softening point test here? Softening point means the bitumen phase will change solid to liquid here beta. Okay, in this test we will calculate the temperature at which the bitumen will attain the particular degree of softening. Okay, in this one we will calculate the temperature at which the particular degree of softening. Particular degree of softening meaning is the bitumen will change solid to liquid phase beta. Okay, so it's very important. Many times question have come. We measure here temperature. Okay, flash and fire point test is conducted for safety point of view. Safety point. Okay, and spot test is used for checking the bitumen is cracked or not. Bitumen is cracked or not. And one more thing we have, specific gravity beta. Can you tell me what is the specific gravity of bitumen? Specific gravity of bitumen, anyone can tell? What is specific gravity of bitumen? Anyone can tell? What is the specific gravity of bitumen beta? The value is 0.97 to 1.02. For tar, specific gravity is 1.10 to 1.25. Okay, for tar, specific gravity is 1.10 to 1.25. So these are the tests for a bitumen. The question is generally coming if, the question is if coming, so it's just coming like a match the following. Okay, but not at all detail is coming from these the test beta. Okay, no detail is coming from these tests, only the data have been asked, or they have asked what the purpose of test. Okay, and here they have asked 1/10. If you measure the reading, it will be 1/10 of mm. Okay, all right. So in that, I think so you know one most important topic is in the highway material, that is, anyone know what is that topic which I am going to discuss now? Anyone? What is the topic which I am going to discuss now? Anyone? Anyone? That is Marshall mixed design. That is our Marshall mixed design. Okay, complete Marshall mixed design is based on the 5 formula. Based on the 5 formulas are there. What is the formula? First formula we have here, theoretical specific gravity. Theoretical specific gravity. This is also known as apparent specific gravity. This is also known as apparent specific gravity, which usually denotes GT. How it is? W1 plus W2 plus, it can be any Wn upon W1 upon G1 plus W2 upon G2 plus Wn upon Gn beta. If W is given to in percentage, the formula can be written as 100 upon W1 in percentage divided by G1 plus W2 in percentage divided by G2 plus Wn in percentage divided by Gn beta. Okay, this is the theoretical specific gravity or apparent specific gravity. Second one we have bulk specific gravity, which is also known as mass specific gravity, which is also known as actual specific gravity. Why actual? Here we are not considering the air void. Yeah, here we are not considering the air voids. Okay, I am writing here no air voids, but practically air voids are present. So actual specific gravity here with air void beta, with air void. So what is the formula here? Gm is equals to W of mold divided by V of mold into gamma W, into gamma W, and GT is always greater than GM beta. GT is always greater than GM because we are not considering air void. So denominator is small, that's why GT value is more. Next we have percentage air voids. Next formula we have percentage air void, which is denoted as VV percentage beta. So VV percentage is equals to GT minus GM upon GT into 100. GT minus GM upon GT into 100 beta. Second formula we have VMA percentage. What is VMA? What is VMA? Void in mineral aggregate. Void in mineral aggregate. Void in mineral aggregate, which is usually calculated as VMA percentage is equals to VV percentage plus VB percentage beta. VV percentage plus VB percentage. VB percentage is equals to WB upon W into GM upon GB into 100. Also I can say this formula WB in percentage into GM upon GB beta. Okay. So VB will be this, VB will be this. Both summation is called as VMA. Both summation is called as VMA beta. Okay. Alright. Any doubt? Any doubt? Last one, in the last we have VFB. In the last we have here VFB. In the last we have here VFB percentage, that is void filled in bitumen. Void filled in bitumen. So VFB percentage is calculated as VB upon VMA into 100. Okay, VB upon VMA into 100. So both will be percentage. So percentage will be cancelled. Okay beta. So VFB percentage is this beta. VFB percentage is this. VB upon VB in percentage you can write, no problem. Both percentage will be cancelled to each other. Okay. Both percentage will be cancelled to each other. Now we have most important thing, Marshall chart beta. Next we have Marshall chart. The question have come many times from this. Now that chart you have to remember beta. That chart you have to remember. Okay. What is that chart? We have 5 graphs here. We have 5 graphs here. That graph have been asked in exam already. Okay. The graph have been asked already in the exam. On the x-axis, it's a percentage bitumen. On x-axis, in the percentage bitumen in all the graph. And in the first graph, it's a Marshall stability. On y-axis, it's a Marshall stability. Marshall stability means it's a load value beta. At how much load specimen is failing, that is called as Marshall stability. Here it is flow value. Flow value again, here it's calculated as 0.25 mm units beta. Okay, here it's calculated as 0.25 mm units. It means if it's given to you, flow value is given to you 16. If it's given to you flow value 16, it means penetration is there 16 by 4, flow 4 only beta. Okay. If flow value given to you 16, so you have to divide it by 0.25, that will be 4 only here. Okay. So here Marshall stability is there, flow value is there, and GM is there here. Here GM is there, and here VV is there. Okay. And in the last one more thing is there, that is VFB. Last we have VFB percentage beta. Okay. Okay. अब बेटा ग्राफ को ना याद करने में बहुत दिक्कत होती है यार. ग्राफ को ना याद करने में बहुत दिक्कत होती है कि कैसे याद किया जाए शेप्स को. राइट. तो एक चीज देख लो यहां पे. देखो सीक्वेंस याद रखना है बेटा. मार्शल स्टेबिलिटी, फ्लो वैल्यू, जीएम, वीवी, वीएफबी. जैसे हमने ड्राइव किया ना वहां पे एक्सप्रेशन, पहले जीएम निकाला, फिर वीवी निकाला, फिर वीएफबी निकाला. स्टेबिलिटी और फ्लो वैल्यू याद रहेगा, नहीं भूलोगे मुझे पता है, ठीक है। यहां पे कंफ्यूजन हो जाता है कि कौन सा पहले था कौन सा बाद में था। तो जीएम वीवी परसेंटेज, वीएफबी परसेंटेज। तो बेटा ग्राफ कैसे करना है, देखो पहला ग्राफ नीचे, पहला ग्राफ नीचे, दूसरा ग्राफ ऊपर, तीसरा ग्राफ नीचे, चौथा ग्राफ ऊपर बट ऊपर, लास्ट ग्राफ नीचे, नीचे ऊपर नीचे ऊपर नीचे बेटा, डाउन अप डाउन अप अप, डाउन अप डाउन अप डाउन। ओके, यही तरीका है याद करने का, कर सकते हो तो, और कोई तरीका नहीं है बेटा, ठीक है। और द क्वेश्चन हैव कम ऑलरेडी फ्रॉम दिस, द क्वेश्चन हैव ऑलरेडी कम फ्रॉम दिस, डाउन अप डाउन। Okay, so these things you have to remember. The questions are very frequent from this. The questions are very frequent from this beta. Okay, the questions are very frequent from this. Anyone doubt? Anyone doubt? Anyone doubt? Anyone doubt? Anyone doubt? Anyone? All right. So this is the complete about highway materials. This is complete about the highway materials. Now let's move to the pavement design. Now let's move to the pavement design. So I hope so all of you know we have two types of pavement. One is flexible pavement. One is flexible pavement. Second one we have rigid pavement. Second one we have rigid pavement, one we have flexible pavement, one is rigid pavement. Now if you see na beta in flexible and rigid pavement, I hope so all of you know, in the flexible pavement you have 4 layers and rigid pavements you have 3 layers, right? So in a flexible pavement we have one thing important, that is modified CBR method. Okay, that is modified CBR method, but before that so many terminology is there. In flexible pavement we have some terminologies are there. What is the terminology here beta? The first term is, I hope so you know, anyone can tell me what is the terminology here in a, the first term is here standard axial load. Standard axial is considered as like that beta, dual wheel in a single axle. The dual wheel in a single axle is considered as standard axial and the total weight is 80 to 100 kg. The total weight is here 80 to 100 kg beta. Okay, total weight is 80 to 100 kg beta. Okay, one more I hope so you know, I am not going into detail of that, ESWL, which you can study, I hope so you have drawn the graph in between the distance and load. I hope so you have drawn the curve between the load and the distance, and based on that you calculate equivalent static wheel load beta. Equivalent static wheel load means if you convert two loads into a single load, how much load we have to apply. No question have come from this up to now. Okay, no question, because the graph is required and the log is required, so question become very lengthy. The question have not come from this up to now. Okay, next we have EALF, which I am expecting the question. But EALF, equivalent axial load factor. What is equivalent axial load factor? That is calculated as L upon Ls to the power 4. L is our axial load, Ls is our standard load beta. Okay, standard load will be given to you in the question. Ls will be always given to you in the question. Ls is our standard axial load beta. Ls is our standard axial load. This is also known as fourth power law. This is also known as fourth power law. Okay, this is also known as fourth power law. Okay, next one more thing we have, total number of repetition. If axials are moving on the pavement, so total number of repetition, how to calculate? Total number of repetition is calculated as how? Number of vehicle n multiply with EALF beta. So sigma of n into EALF, n1 into L1 upon Ls to the power 4 plus n2 into L2 upon ls to the power 4 plus dot 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 dot. So if total number of repetition question is asking to you, you have to apply this method beta. Okay, if question is asking to you this, so you have to apply this method. L and sigma of n into EALF. N is here, I am writing n is here number of vehicle. N is here number of vehicle or number of axles, sorry. N is here number of axles. N is here number of axles. Okay. Next we have rigidity factor. Next we have, anyone know what is rigidity factor? Rigidity factor, anyone know what is rigidity factor? It is defined as the ratio of contact pressure to tire pressure. Contact pressure to tire pressure. Okay. So if rigidity factor is greater than 1, less than 1, if it's a greater than 1, the tire is in under compression. If it's less than 1, tire is under tension beta. Okay, it is useful for checking the degree of tension on the wall. Okay, it is useful for checking the degree of tension on the tires wall. So contact pressure divided by tire pressure beta. Okay, all right. Just a minute, let me have some water. After that we have a modified CBR method beta. After that we have modified CBR method which will be used for designing the pavement. So I am writing here modified CBR method. I hope so all of you know the formula. In this one what we do, we calculate cumulative number of axles. Okay, cumulative number of axles. The formula is 365 A into 1 plus R to the power n minus 1 upon R. Right, A is our anticipated traffic. A is our anticipated traffic at the time of construction completed. Means after completion of construction, how much traffic is there? That is our A. R is our rate of growth. N is our design period. N is our design period, and here we multiply with 3 factors. One is vehicle damage factor, one is lane distribution factor, one is LSF beta. 3 factors are there which we use here. Okay, 3 factors are there which we use here. One is vehicle damage factor, LDF and LSF. And one more thing I want to add here. In this one, this method is based on the number of axles. So here we consider only the commercial vehicle beta. Okay, only the commercial vehicle will be considered. Okay, what is commercial vehicle? If weight is more than 3 ton, that is considered as commercial vehicle. Okay, so whatever axles we are counting here, that will be commercial vehicle. Now what is VDF? VDF is our vehicle damage factor. That is our vehicle damage factor, which is calculated as same like that. You calculated this beta, same like this. So what it will be? N1 into L upon Ls to the power 4 plus N2 into L1, L2 upon Ls to the power 4 plus dot 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 divided by N1 plus N2. Okay, so VDF will be calculated like that. Next is our lane distribution factor. In now actually for the flexible pavement design, the new code have been come in in year 2018. After in 2018 the new code have been published. So that lane distribution factor is also called as lateral distribution factor beta. This is also called as lateral distribution factor. In 2018 the code have changed the word lateral distribution factor. Okay, it is lateral distribution factor, which I am supposing in the exam will be given to you. One more thing, but one thing I want to add here, maybe you have the data here. Intermediate lane was not added in the previous code, but in a new code intermediate lane is also added. So the value is here 0.75 for intermediate lane. Okay, For intermediate lane, LDF value is 0.75. And LSF is our load safety factor. This will be used if the traffic will be unpredictable, right? I designed the pavement today, maybe tomorrow the traffic have been more. This is our load safety factor. Like you use the safety factor while designing your RCC and all, right? So this is our safety factor beta, which is for a unpredictable traffic. Okay, so this is our modified CBR method. All right. So flexible pavement, only the CBR method is which is most important in our course, right? Next we have rigid pavement. Next we have rigid pavement. In rigid pavement, I hope so you know, first we have radius of relative stiffness. First one we have radius of relative stiffness. Okay. Second one we have radius of equivalent section. Radius of equivalent section. Okay. What is the formula here? L is equals to, I hope so you know, EH cube upon 12K 1 minus mu square to the power 1 by 4. What is E? Young's modulus. H is our thickness of the slab. K is our modulus of subgrade reaction. Mu is our Poisson ratio, right? And what is this? Radius of equivalent section. Here we have two cases. Here we have two cases which is denoted with B actually. B is equals to under root of 1.6 A square plus H square minus 0.724 H, or B is equals to A. B is equals to A. This is, sorry, 0.675 H. 0.675 H. This is the case when A is less than 1.724 H, and this is the case when A is greater than 1.724 H beta. Okay. This is the radius which is effective in a soil. This is the radius which is effective in a slab. Resistance against the bending moment. This is the radius which is against effective in a slab for resisting the bending moment beta. So this is our rigid pavement here. So in the rigid pavement, basically, I hope so you know, stress in rigid pavement. Two stresses are there. One is wheel load stress. Second one we have, anyone can tell, that is our temperature stress. So in temperature again we have two type. One is our warping stress. Second one we have here. Anyone tell me? Warping. Other one we have frictional stress beta. Other one we have frictional stress. So warping stress due to daily change in temperature. Frictional due to seasonal variation. This is our seasonal variation. This is due to seasonal variation beta. I hope so all of you know this thing, right? Next one. Next we have what is the nature of these stress beta? Okay, so I am making one table here. I am making one location. Interior. It can be the interior of slab. It can be edge of slab. It can be corner of slab. Okay, now it can be top of interior or bottom of. Again top, bottom. Okay, now here the stresses are now. Here it's a wheel load stress. We have wheel load. Second one we have warping and frictional. So now I hope so you know, in interior, the top, the stress will be compression and tension. Here it will be compression and tension, and here it will be tension and compression. Okay, and warping stresses are due to daily change in temperature. So here it will be daily, means it can be daytime, or it can be night time. Similarly here frictional will be in a summer, or it can be winter. So in a daytime, in an interior, how the stress nature will be, anyone can tell? It will be compression, tension beta, and here it will be bottom, it will be tension compression. Similarly here it will be at the top compression, tension, tension, compression, compression, tension, tension, compression. And here in a summertime it will be compression at all the places and it will be tension at all the places. Okay, so this is our nature of stress. This is our nature of stress in the rigid pavement. So here you can see, if I ask you the critical combination. So interior we have to no need to, because interior so much area is present, so slab will not fail. So most critical section is edge beta. Okay, most critical edge where, as you can see, concrete loves compression, so no need to see, only see tension. Here tension is there. Okay, here tension is there. Here tension is there and here tension is there beta. So now winter time in a day, okay, in a daytime, edge will be most critical on the bottom. Okay, if you see the corner, in a corner at the top tension is there. Okay, and here you see, here tension is there and here tension is there. So in a winter, in the night time, on the top, the corner region will be most critical. So critical combination have been asked in the exam. So you can see edge is the most critical beta when in a winter, in a daytime, and the top. Winter in a daytime at the top, it's the most critical. Sorry, in the bottom, not top, it's a tension. So in the bottom, in a winter daytime, it will be a most critical. Okay, it will be a most critical combination. Okay, and the frictional stresses are maximum at the center and zero at the corners. Okay, the frictional stresses are maximum at the center and zero at the corner. So I am writing the formula of frictional stress also. The frictional stress can be calculated as SF is equals to F gamma Lx by 2. Lx is our, F is our coefficient of friction. F is our coefficient of friction. Gamma is our unit weight of concrete. And Lx is our slab length. Okay, so this is our frictional stress can be calculated. SF is equals to F gamma Lx by 2. Other than that, we provide here, we provide expansion joints. Okay, we provide different joints in a pavements. So I am not going in that much detail. First one, we have expansion joint. Okay, expansion joint, why do we provide? We provide for transferring the load. Okay, this is provided. Okay, this is provided when? This is provided one. Okay, expansion joints are there, like if their slab is there beta, and here other slab is there. Okay, so these joints are in between that is our expansion joint. And here we provide one bar that is called as dowels bar. Okay, these bars are called as dowel bar. And other thing you can see here, if one more slab is here, let us suppose, so for joining two slab we provide tie bar. Okay, for joining two slab we provide tie bars here. Okay, so now spacing of, I hope so you know, spacing of expansion joint. If I say this gap is delta, so it's considered that delta by 2 is equals to L alpha into delta T. Why delta by 2? We assume that whatever filler is there in between that, it will be compressed by 50%. So delta by 2 is equals to L alpha into delta T. Okay, next we have tie bar. Length of tie bar is calculated as similar to RCC, twice of LD. So twice of phi sigma st upon 4 tau bd. I hope so you know. Okay, twice of LD, twice of development length, which you already studied in RCC. So twice of phi sigma st upon 4 tau bd. So this is our length of tie bar. Okay, and tie bar is provided to hold the slabs, to hold the another slab. To hold the another slab. Dowel bars is provided. Dowel bars is provided for transferring the load beta. For transferring the load, we provide dowel bars. Okay, and it is designed for 40% of wheel load. It is designed for 40% of total wheel load. Okay, the dowel bars are designed for 40% of total wheel load. Okay, so this is completely all about the pavement design. This is all about the pavement design. Next we have railway engineering. Next we have railway engineering. So in railway engineering, only one thing is there which is most important. That is our super elevation beta. That is our super elevation. So in a railway we have a different gauge. I hope so you know. We have a BG gauge, we have a MG gauge, NG gauge, broad gauge, metric gauge, N gauge. Okay, and here it's a 1676 mm. Here it is 1000 mm. Here we have 762 mm beta. Okay, the question is expecting only from the super elevation. The question is expected only from the super elevation from this. The formula is E is equals to GV square by 127 R. Here E is our equilibrium super elevation, you can say. Equilibrium super elevation, or you can say actual super elevation. Okay, this is our actual super elevation, which is provided based on, here V is our average speed. Here V is our average speed. Okay, it is provided based on average speed beta. Okay, so now if you provide based on the maximum speed, that is called as theoretical specific. Okay, that is called as theoretical super elevation. If I use here maximum, this is called as our maximum theoretical super elevation beta. Okay, next we have here what is the maximum permissible limit of this? Permissible limit, gauge, permissible limit. What is permissible limit? For broad gauge, metric gauge, NG. Okay, it's a 1676, so it's a 165 mm. Here it's a 100 mm, and here it's a 76 mm. Okay, or you can say 16.5 centimeter or 10 centimeter. Also you can say it's a 7.6 centimeter. Okay, all right. One more thing, I hope so you know here. Radius is calculated as 1720 upon d. How this formula is coming? Arc upon 2 pi r d upon 360. The formula is coming like that, right? Arc here, generally the chain is considered as 30 meter. Okay, so 30 meter upon 2 pi r d upon 360. You are getting the formula of radius from this beta. Okay, and now if I come to the Kent deficiency, meaning is this: we provide the super elevation based on the actual average speed, but sometime when the speed train have a more speed, so super elevation will be less. In that case, we have to provide the more super elevation. That lesser super elevation is called as Kent deficiency. So E theoretical is equals to E actual plus D, where D is equals to Kent deficiency beta. Okay, E theoretical is equals to E actual plus D, that is our Kent deficiency. Okay, now what is the value of Kent deficiency? Again, gauge and speed, if speed is less than 100 kmph. Broad gauge, metric gauge, narrow gauge, here the value is 75 mm, 50 mm, 40 mm. Okay, so these are the permissible limit for the Kent deficiency. Next we have negative super elevation. Next we have negative super elevation. Negative super elevation, I will say to you, remember one thing only: E actual of main track is equals to minus E actual of branch track. Just remember this relationship. Other than you know, E theoretical is equals to E actual plus D. Okay, just apply this thing, all the questions will be solved beta. Okay, I cannot go in the detail of this, it will be very lengthy. Negative super elevation is E actual of main is equals to E actual of branch. Okay, so this thing you remember only, all the questions will be done. Right, next we have Next we have grade compensation here also beta. Grade compensation here also is there. What is grade compensation? For BG track 0.04 degree, sorry 0.04% for 1 degree. For metric it's a 0.03% for 1 degree. For NG it's a 0.02% for 1 degree. Okay, so this is the railway thing. This is the railway thing for per 1 degree, for per degree, or let me say for 1 degree, or you can say. Okay, so this is our grade compensation in the case of railway engineering. Okay, again the gradient will be given to you, ruling gradient minus grade compensation, you will get the compensated gradient, which we have done already, right? Next we have airport engineering. Next we have airport engineering. In airport engineering, only the important thing is the corrections. Only the thing is corrections. What are the corrections, beta? We have 3 correction here. First one is elevation correction. What is that? 7% for elevation for 300 meter elevation above MSL. Above MSL, beta. Okay. For every 300 meter, we have to provide 7% correction. Next one we have temperature. Temperature correction is, in this one we calculate rise in temperature. That is calculated as ART minus SAT. What is ART here? ART is our airport reference temperature. ART is our airport reference temperature. Okay, which is calculated as, anyone can tell, TA plus TM minus TA upon 3. Okay, and SAT is our standard atmospheric temperature, standard atmospheric temperature, which is calculated as 15 minus 0.0065 H. Okay, H is our elevation here. H is our elevation. H is here elevation. Now what is TA and TM? What is TA and TM? TM is mean of monthly average, mean of monthly, what is here? What is TM and TA is there, beta? TA is what? Mean of, very good, Bhagyasri. What is TA and TM here? What is TA and TM here? TA is our monthly mean of average daily temperature of hottest month. This is our mean of monthly maximum daily temperature of hottest month. Okay, and after it you will calculate rise in temperature and 1% for every 1 degree rise in temperature. Okay, the correction will be 1% for every 1 degree Celsius rise in temperature, beta. And cumulative elevation and temperature correction cannot be more than 35%. Okay, the temperature, both the combined correction cannot be more than 35%. Okay, it cannot be more than 35%. Next we have gradient correction. What is gradient correction? Anyone can tell? For every 1% effective gradient, for every 1% effective gradient, 20% increase. Okay, now what is effective gradient? What is effective gradient? Effective gradient is equals to beta RL of highest point minus RL of lowest point divided by runway length, basic runway length after these two correction. Okay, after elevation and temperature correction beta. Last year only the problem have come from this. Okay, last year only in GATE 2021 the problem have come from the effective gradient. Okay, so last year only the problem have come from this. So this is the complete about the airport engineering. Okay, exit taxiway design is there and radius of exit taxiway is there, but I am not expecting, the expected questions are only from this. Okay, in the railway the questions are expected from super elevation, and here the question is expected from the gradient part, sorry, corrections of airport beta. Okay, so this is the completely transportation engineering. I don't think so I missed any formula. I have not missed. Okay, the concept you may just see the pavement design stress part once again. Okay, just because due to the shortage of time. Okay, but other than that I have not missed any formula. You can just go through all the formulas. Definitely you can try all the problems. No question is there beyond these the formula beta. Okay, so anyone, any doubt from your side, anything from your side? Anyone, any doubt from your side, anything? Alright guys, see you on Thursday. Thursday I am going to take the structure analysis part. Okay, Thursday I am going to take the structure analysis part. Okay, so maybe you will learn so many new concepts. Okay, so many shortcuts to solve the questions on the Thursday. Okay, anyone, any doubt you can ask me. Alright guys, see you on Thursday. Thank you for joining. Very good night.